Hello, good morning, Gregorio.
Good morning.
Hello, Reet, how are you?
Fine.
Yeah, fine. Yeah.
So we are starting with the last day's proceedings today. And I'm sorry, Gregorio, for a heavy day today. Again, the last day.
Yeah, no problem. You know, for me talking about free software is no problem.
Okay.
No, I can talk for hours. I hope it's interesting for the audience. That's number one, and that they learn a lot.
Yes.
So
let's take some feedback from Amrit before we start. Amrit, are you enjoying?
I'm really well.
Okay, thank you. So Gregorio, you can start anytime.
okay, I see there are how many 26 in the room. Yeah, I think it's a good number to start. Let me put the chat in the other laptop. Okay. Morning, everybody. We've got 4 sessions today.
Yeah. And we will have a valedictory session in between at 4 o'clock.
Exactly. So first we're going to talk about processes, development processes, then about software analytic tools. Then we'll have a longer session with hands-on, where I will show some tools and what to do with them. And yeah, and then we've got the firewall. Good. Let me see and share my screen. 1 second. I'm sharing my screen. And yes, I think you should see my slides.
Yes.
So fantastic.
Thank you.
So as I was saying before, the first session is going to be on free open source development processes. As you already know, if free software, those who talk about free software, they are more on the ethical side, and they think free software is good per se, and that's how it should be. Those who talk about open source, they have more a pragmatic perspective. And one big thing from the pragmatic perspective is about the development process. That it's the development process in open source is more it's more efficient than the traditional one. One important thing to notice at this point is that that's why I put the processes in plural here in the slides. Really, there is no open source development process. There are many, or as many as software projects, but there are some common trends that you see in most of the projects. I say that because actually any company or any individual can start an open source project, and you know how it works. You put a license there, and by having that license, that's already open source. And you can follow a process that you want, and there's no commitment to any process. But let's say experience has shown that there are some ways of development, and we talk development in the open, in community-driven development that makes the development process more efficient. And that's what we're gonna talk about. And actually, we're going to talk about it from a more historical perspective, so that you understand where the roots of this open source development processes come and why people think like that. And I will devote a final slide at the end of the lesson to show you how it actually is being done today, which is maybe slightly different than like 25 years ago, and probably different than in 10 years time. But the roots, the fundamental parts stem from these ideas that Eric Stephen Raymond, which is this guy there in the slide, put very well in an essay like in 1997. So this, as it says, Eric Raymond was a very reputed software developer in the 90s, and he's the author of FetchMail, GPSD, and the Emacs editing modes. And he was a big fan of the Linux kernel. And at first, in the mid 90s, the Linux kernel became a big success, an unexpected big success. You have to think that's when the internet got popularized. The internet was first just an academic network, and then in the mid 90s, it grew to something where many more people had it at home. And the development process of Linux, and the one that Eric Raymond looked at, was based on collaborating over the internet, and that was of course new. And well, he was fascinated by the development method. No? So he published this essay, which was, he said, the cathedral in the bazaar. I mean, as you see, even the way he named the essay says much about the writing style of the author, of Eric Raymond. And he became a prominent voice in the open source movement. No, Eric Raymond, if you remember the day, 2 days ago, when we talked about FLOSS leaders, he was ranked third after Linus Torvalds and Richard Stallman. When the question was, do you know this guy? Not necessarily personally. So over 80% knew Eric Raymond, and that's because of this, because of he wrote this essay, and then he has very strong opinions and so on. And then he was one of the founders of the open source initiative. So that was 1 year after publishing this essay. He came together with other people and said, we have to focus more on the practical issues. And the name free software, because of free, that's polysemic, and people might think it's gratis and so on. Let's have a more business-friendly term, and we should go for open source, which actually puts the emphasis on those things that we're talking about the cathedral and the bazaar. So this essay was written originally in 1997, and there are different versions. I mean, you can, if you Google for it in cathedral and the bazaar, you have it in well, there's a Wikipedia page, but here you have a website where you can download it even in very different languages. And here you see, well, another picture of Eric Raymond and so on. So there were several revisions then in the first years, where he changed slightly the essay, because one of the things that is very interesting, I mean, he described the Linux development model at that time. It has also changed a little bit from now they use different tools and slightly different perspective, but he described that model, and he tried to replicate it in another project to see if how it works and so on. So that's the interesting part. And the model is presented as revolutionary, since it's the first time that such a large software system was developed apparently without any organization at all, or then any big IT company behind that. So that was something that at that point was incredible. So it's like also I think one of the Jimmy Wales, which is the founder of the Wikipedia, was heavily influenced by this writing, because this collaborative working around the internet. And if you think about it, that I like that quote that says, yeah, Wikipedia is only a reality in real life, if you think about in theory about it, it wouldn't be possible. And something that is similar here in Linux. I mean, if somebody tells you that developers over the internet work together without being let's say hired by a company and without having contracts and so on, and somebody tells you that in the early 90s, you would probably say that's not possible. That's not going to happen. And actually, the only way to believe that is because you saw Linux and you ran it in your machine, and then you said, "Oh, this works." So what's the cathedral and what's the bazaar? So Eric Raymond stated that the cathedral was the classic software development model. So it's a closed environment with a small group of leaders, developers. They only release stable versions, and in some cases beta versions, but you don't see much more from the development process. You don't see the daily status, and you see there waterfall and spiral classic models and so on. No? And actually, even if it's thought for traditional software development environment, as you would have seen in at Microsoft and at Oracle and so on, Eric Raymond said that this cathedral model was also seen in some other free software projects like GCC, that's the GNU C compiler, or GNU Emacs. So actually, that's the way software was developed usually. So just here, if you think about the GNU Emacs, it was Richard Stallman, one of the main authors. So they, in the small group, and there were the ones developing this software, and they then it was not that open to contributions from the outside. So that's here the point about the bazaar, which is the model introduced by Linus Torvalds. And the bazaar, in the words of Eric Raymond, is an open environment where almost any person can participate. There are no clear leaders. There's an undefined number of developers. People come and go. And even he says that there are no clear leaders here. They have a benevolent dictator, a leadership. So there's some sort of leadership figure and so on. There is release early, release often, which we will talk about afterwards what this means. But actually, it's that the development cycle is very fast, and you see new versions coming out there very frequently. And here the example was Linux at that time. And then you look here about the cathedral. Everything is pre-designed, and everything is, let's say, with hard processes. And think about the bazaar, which is everything is to some extent unorganized, and depending on the interest of people, they go to one place or the other place, and there are more people involved in the decisions in the bazaar than in the cathedral. Actually, to the extreme, everybody in the bazaar is free to choose what to do and so on. And those were the models that Eric Raymond had in his head, and that's why they named it one or the other way. And as you see, it doesn't depend really on open source software or not, because his point was all the software before was done in the cathedral, and the new wave is the bazaar, as understood by Linus Torvalds. And Eric Raymond thinks that open source software should go the bazaar model to be more efficient. So that's here the surprise is with the bazaar style of development. It seems feasible to create large and complex software systems, which is something surprising at all from the software engineering point of view. Very, very surprising. So if you look at the software engineering books from the 70s and 90s, they were always thinking about control, and this was not a way of developing software. This was chaotic. You don't control how do you assure the quality and so on. And so here the point with bazaar is you have archive repositories, and anyone can propose a modification. And then from this repositories, a stable, coherent, large system emerges, which is part of this magic. So the surprise is why, if this looks like such a chaotic way of development, and you think about the bazaar, and if you think about the bazaar, the first thing you think about is chaos. I mean, there is no control, really no organization, or no apparent organization. How does Linux not go into confusion? And the second thing is, it's not only into confusion, but it builds a very strong system, and it does at a speed that is barely imaginable for cathedral builders. Think that if we think about the classic examples of cathedrals in Europe, it took centuries to build some of the cathedrals. So sometimes they start with an architect, and then it takes 100, 200 years to finish the cathedral. That's a very long process. So that's a little bit so if Eric Raymond goes over the processes or the process that you find in Linux, and he extracts some lessons. And one of the things that I'm doing here is just I point out the most relevant lessons that he announced, and I will present them a little bit so that you see what is behind the open source development mentality of what a process should look like. So the first lesson is, every good work of software starts by scratching a developer's personal itch. So Eric Raymond notices that most successful open source software was started by developers who had a necessity, and they started a pet project. And this pet project became bigger and bigger because others started to collaborate, and then it became something relevant. And he puts there some examples, and Linux is one of those examples. So it was a pet project of Linus Torvalds, and then it became so. And he says that in the world of proprietary software, this doesn't happen, because programmers there spend their time creating software that they neither need nor want. So that's it's different to program for yourself than for other people. That was his point. And if you think about that, then that's why probably quality is higher, because you know about your necessities and you know what you want. And then that's something you see quite often in open source, is that the program is the result of an own necessity, and then that makes that it's very focused on the practical or fulfilling these necessities. So that's lesson number one. And lesson number two is says like this: good programmers know what to write, great ones know what to rewrite and reuse. So just think that Linus Torvalds really didn't start from scratch. Instead, he started reusing Minix ideas, not Minix code, because Minix code at that point, Minix was a kernel, an academic kernel that was studied at universities by Tannenbaum, which is a very famous Dutch professor. And probably he's got this big books, this famous books on operating systems and computer networks, Tannenbaum. And he had a small kernel which was called Minix. And then some of the ideas from Linux stem from Minix. And actually, there was when Linus released Linux, and then people started to collaborate in Linux, and then Andrew Tannenbaum wasn't very happy about that, and he didn't like Linux because it was let's say a kernel that didn't have like modern characteristics as Tannenbaum thought that Minix had. And then there's a debate which between the both of them and so on. So as you see here, it's the Minix code was removed and rewritten, but it was there providing some scaffolding. So that was a big thing, no? And here it says, and that's very important. So the source sharing tradition of Unix systems came here to code reuse, and that's something that we see quite often today. We have lots of source code out there and lots of libraries. And if you think there is this almost in any environment in open source, there is a stack of already built technology that is quite stable and so on. And that makes that if you want to build something new, you don't need to start from scratch. You can reuse, and you can build on. No, you can start on the shoulders of giants, and that's very important. That has to be seen as an advantage of open source software. Now with all the source code that you have there, that's an important lesson. Lesson number 3 is plan to throw one version away. You will anyhow, and that comes from the Mythical Man Month from Fred Brooks, which is a very famous software engineering book from the 70s. And this comes because you usually don't understand the problem at first, and until you have an implementation. And then once you have an implementation, you see, aha, this is what works, and this is what doesn't work. So let's go and throw it away. So here, this also has to do with the versioning system that is adopted. So usually you have you start with 0 dot something versions, and then at one point you change to 1 dot versions and to 2 dot versions, etc. And sometimes you have to re-architecture everything because you have understood the problem better, and you have to change the architecture to grow in a better way. And that's lesson number 3. Then this, I find this very interesting. This actually doesn't happen very often nowadays, because you say when you lose the interest in a program, your last duty is to hand it to a successor. Even if it doesn't happen very frequently, in the sense that you release something which is a pet project, and then if nobody comes, you forget about it and so on. But if it starts having some success, and you leave the project, then you try that it is still maintained and in good hands. And I like this lesson. I think that what it says is here, this sense of community that rises. I mean, it's the software, and then you should try, or you should strive for a community around a program, so that you have a successor there. Is in the case you want to move on and go to other projects, and then that's where you start seeing that this is a very important issue here, having a community around the software, and that's something really new. And that's lesson number 6 goes in the same part. It's more detailed, but say treating your users as co-developers is your least hassle route to rapid code improvement and effective debugging. So Eric Raymond saw that in Linux, many users are hackers too. So they just think they are operating system kernel users. So they are very specific type of users. It's not like end users as in the Office suite. So here, many of them they were hackers. So they actually had the skills and the knowledge to contribute to Linux. And because the source code was available, these users can be effective hackers in the sense that they can participate. So if there's a problem, instead of just sending an email saying there's here a problem, what they can do is they can debug, and even they can state what the problem is. They can give more information about the problem, and even they could solve it and suggest fixes and help in improvements. So the idea here is make sure to treat your user community well, because they can become contributors. They are potential contributors, and if they're contributors, they're contributing and providing value to your software project. And of course, that's here the radical idea in all the essay. That's that you don't only have users, you have users that may become contributors, and then they also help in driving the project forward. Lesson number 7 is very famous. It says release early, release often, and listen to your customers. So there was during the early days of Linux, there were many versions released. There was almost a version every week. So there were new features coming into the source code, and they were released, and sometimes even more than one in a day. So you got constantly evolvement and so on. So this makes that hackers are constantly stimulated and rewarded in the sense that you get a new version, they test it, and then they debug it. They found the bugs. They sent this fixes for the bugs and so on, and this comes the day afterwards into the new version. So you see, if you contribute, it's out there in the public in a couple of days, and people can benefit of your hack, and that's very, very stimulating. No, this say that's an ego satisfying piece of the action. No, and it's rewarded by the sight of constant, even daily improvement of their work. This has changed because this release early, release often. Well, release early means that you should release your software as when you have a minimum working software, so that people see that you are working on it. And then release often is that once you've released this minimum version, then you should be still releasing it quite often, so that people see there is activity and that there are new features and so on. That's the release early, release often principle. This has changed because, well, especially in some environments. So just think this is Linux is a very hacker-friendly environment, and then that was the attitude there. But if you have traditional end users, they don't want to have so many versions. They want some stability. So nowadays, many big projects, what they do is they have a big release every 6 months, which they call a stable release, and some of them are long term maintenance modes, in the sense that let's say I think every fourth of them they say, so in this version we're gonna maintain it for 5-6 years, and the other versions are going to be maintained for a couple of years. So that means that companies can say, okay, I will take this version, and we are sure that it's going to be maintained. We don't want new features. We don't want new things. We just want bug fixes there and so on. And this is going to be our system for the next 5 years, which in technology is a lifetime. And so this release often culture you don't find specifically as such. On the other hand, what has happened is that if you want to see the latest version of the code, you have there the Git repository somewhere on GitHub, GitLab, or whatever. So there's still the possibility, even if the last release was months ago or even years ago, that you take the latest snapshot of the code, and that you can do that. So there's now a differentiation, let's say, between developers and let's say end users. So I see there's a question here, which says frequent releases. So once in a day may keep the users on toes, isn't it? And yeah, that's the problem. So that's if you're not that much into the development process, just imagine you install one version and then the same day another version comes in. So now this only happens if there are if there are security updates or things like that. No, you release a new version, and then there's a security issue, and then that's the exception. Then you introduce those changes to fix the security bug, and then you release a new version as soon as possible, and you try that your users update to the latest version. That's the only. But as I say, that was in Linux in the mid-90s. That was not the case. The community was different. Now it's a community of users, and it's by far much larger. The open source community, it's almost now, so as we were saying in the previous day, it's pervasive and you can find it everywhere. So it's different than the community in the early 90s, where were mainly techies and people that or hackers, as Raymond tell them. So that has changed, but the fundamentals behind is, if you want to have access at the latest source code, you can have it nowadays, not through a release, but you go to the repository and you can see there what. No, and you saw yesterday I was doing the humanitarian free open source lecture from Dr. Kuljit, and you saw when is the last commit? Like 10 minutes ago. So you could eventually download it to your computer and you would have the latest version, which might not be a release. So that's important. So and then there's another here lesson, which is given a large enough beta tester and co-developer base, almost every problem will be characterized quickly and the fix will be obvious to someone. This comes from the point of view of open innovation in the sense that there is so much intelligence out there. And if you engage this intelligence that is out there in the benefit of your project, then you will find somebody who knows about the problems that you have and who can create a fix for that. So a different way to announce this lesson is given enough eyeballs, all bugs are shallow, which is called Linus's law by Eric Raymond. So somebody finds the problem, somebody else understands it, and maybe one of those fix it or somebody else, and that's the way to go. So that's why we have tools where you can issue a bug. You can say, here, I found this bug. Then somebody can take this information, can make a bug fix, and then we have a new version of the software without the bug. No, and important here is the difference between the cathedral and the bazaar. In the cathedral, builder view of programming bugs and development problems are tricky, insidious, and deep phenomena. So let's not make it possible that someone else touches our code, because our code is complex and so on. That's part of our development team, and that's something for insiders. But in the bazaar, bugs are generally shallow phenomena. They turn shallow when exposed to thousands of eager co-developers collaborating in the next release. So here it's show the code, and then people will find the place where the bug is and submit bug fixes and so on. So this let's say lesson, given enough eyeballs, all bugs are shallow, is of course an exaggeration, in the sense that there have been bugs in Linux for years. There are some interesting papers where you see the longevity of Linux bugs, and you can see when they fix it, you can see when it was introduced, and there have been bugs for 15 years in Linux even. And that's but the thing here, it's more than taking it literally. The point is how, again, the importance of the community. In the cathedral, you would have there are a small number of developers who are the only ones who see the code and who manage the code, and they then touch the code. While in the bazaar, it's just it's open for everybody to collaborate. And if somebody fixes the bug, then of course that's more than welcome to then get merged into the source code, and then we have better source code. And in the long run, with the internet and with the tools that we have today, then you see this is if you have a good and healthy community, this is a very good way of development. That's why the pragmatics go open source and say that's a better development model. So in lesson 10, it's when Eric tries the model. So he made 9 lessons. I've taken out the most important ones, and what Raymond does is he replicates this model on projects of his own, doing release early and release often, adding to the beta list everyone who contacted him about the implemented program. So he had an authors list, and then he put the names there to boost their ego and to see that they are contributors and that they are valuable, these contributors. They announced the new releases to a mailing list, stimulating people to participate into saying, these are the new features and so on. So come and use my software, and you're more than welcome to participate. And then listening to beta testers, polling them out, designing decisions, and taking consideration. So hearing your community, having an ear for them, and making them know that their feedback is important. So, and the consequence that Eric Raymond says is if you treat your beta testers as if they're your most valuable resource, they will respond by becoming your most valuable resource. That's the lesson. And then he adds 2 more lessons. So the next best thing to having good ideas is recognizing good ideas from your users. Sometimes the latter is better. And often the most striking and innovative solutions come from realizing that your concept of the problem was wrong. So here again, it's hear your community. The community is the big part. No? And then Eric learned this when he saw good ideas for his application suggested by the users. No? And he puts there some examples of how things were working in his programs, and then what users told him and said, oh, that's true. I should go that way. No? And the way I was looking at the problem was not the right perspective, and that's important. So of course, this is an essay, and it's not a scientific paper, and it's not an accurate description. And even the name, the cathedral in the bazaar, as if you look at the models, the analogies are not always 100% true. So there is nothing scientific here. It's more an essay about how it should be, and the words are always very exaggerated. No, and it's not a systematic way of looking at the project. So what Raymond tries is to generalize the case of Linux to all free software projects, and say that this model works for everybody, and that's there might be some limitations. We were talking that Linux users are usually very talented ones, or at least they have a technical background, a strong technical background, which might not be the case for all software systems. And some critics even say that Linux is in fact an example of the cathedral process, because yes, even if it looks like there is no organization, there is a leader there, and there is a hierarchic structure of people with delegated tasks. So it was not Linus Torvalds doing everything. So he had his lieutenants, second level leaderships, where they were in charge of parts of the Linux kernel. So there were responsibilities that were distributed, even if that structure was not explicit, although nowadays it is. So there is some organization. So it's not that something comes there totally unorganized. No, and that's what the critics. And then the point, if all free software is like the bazaar, and one of the problems is that if you look at at GitHub, and there are millions of projects on GitHub, and they mostly have a free software license, but very few have a community behind them. So the rest of them, are they really bazaar? Because to become bazaar, you need many developers. So most of them are really not bazaar style, and that's certainly true. There are some papers who say there's a cathedral phase as well at the beginning for every project, where the project is small. And then if it gets successful, and that's a big if, because not every project gets successful in the sense that it starts building a community. If it starts building a community, then it moves to the cathedral, to the bazaar mode. And that's a different step, because you move from something where all of you have very few developers and you know them by name, and at one point there are thousands of contributors, and their contribution starts coming in, and you need some type of organization that is different from the other one. So this bazaar definition may not be accurate. It's a moving picture. And then free software maybe it's not a bazaar. No, it's that's the other thing. I mean, Richard Stallman, who's more about the ethical things, he says free software is just free software that is released with software that is released with the 4 freedoms, and the other things about the bazaar and so on, that's not that important, and so on. And if you look, GNU Emacs is still developed, let's say, more the cathedral way also, but then it uses this has changed in the last 20 years, and it's taking for granted that if you go to a bazaar model where you try to have everything open and that everything can collaborate, then you use this a certain type of tools, the ones that you mainly see in GitHub, and then you can follow open development processes. And then there was a research paper, or more a commentary from Metzrokov, and then which is stated a second look to the cathedral in the bazaar. And then he criticizes the some of the things in the cathedral and the bazaar. So one of the big things here is, well, he says that given an eyeballs, all bugs are shallow, that this is not really true, that this is a big exaggeration, as we've noted before. And there is a big discussion if Linux belongs to the cathedral model or the bazaar model, because it's not so democratic at the end. You see that Linus Torvalds is somebody who has a very strong opinion sometimes, and he is the one deciding what comes in and what doesn't come in. So it's that's why he's called the benevolent dictator. And he says Linux is his pet project and is still his pet project, and and you are free to have your own Linux version. And there are many Linux versions out there. So the one he releases his Linux, and that's what he decides, no? And probably there is a small amount of kernel core developers who follow the cathedral model, because there are 4 or 5 developers that are key developers, and they develop 80% of the code. And then at that time it was smaller. Now it's probably bigger and so on. But they follow more a cathedral-like model, no? And always the question if the OSS development model automatically yields the best results is a good question. So I guess that has to do with the part that many of the projects don't get to the bazaar stage where they have a community around them. In any case, this writing by Eric Raymond had a lot of influence in many people. So if you go to that time, at that point when the internet was really starting and the World Wide Web was becoming popular, there was at first one web browser which was called Mosaic, and many of the people from Mosaic moved to build a company which was called Netscape, and Netscape was a browser company, and that was the first, let's say, widely used browser in the world. But then Microsoft, who had a large market share in operating systems with over 90%, then they create Internet Explorer, and then the browser wars become, and it was if you installed Windows, Internet Explorer was part of the Windows installation. So this was a way of getting market share in the browser. Was it at some point in 1998? The people at Netscape saw that they couldn't fight against Netscape, so against the Internet Explorer, and that Internet Explorer was having was growing very fast and so on. So they read Eric Raymond's paper, and what they did is they released their software under something that became Mozilla. So if you use Firefox today, Firefox, of course, 20 years afterwards, or more, almost 25 years afterwards, is a sort of a sibling of Netscape and so on. So they released the software, and this was a very, very, very big thing those days. So it was a company, a very well-known company. Everybody knew about Netscape, that was going open source and releasing their software, which is a process that is not that simple. And the second one, let me drink a little bit of water. The second one is the Wikipedia we know. So Jimmy Wales, which is the co-founder of Wikipedia, he read this writing, and he was very, very impressed about it, and said, "Oh, what if we use the same practices for creating an encyclopedia?" And well, you have there the results, no? And think about the encyclopedias that existed before the Wikipedia. They were on book and so on. So I'm thinking about the British encyclopedia, and how they created the content, and how Wikipedia creates the content, where everybody's potentially invited to contribute. No, there's of course some rules, and there is some structure and so on. The Wikipedia is a case study by itself, but it was influenced by the cathedral and the bazaar, and that's the important thing here. No, and now it comes to the current status of the processes of how usually projects work. And you see it here in this in this figure. So now we would say the pull request model that GitHub proposed like 10 years ago, a little bit more, 14 years, 15 years ago, is the one that is mainly used by by software projects in one or the other way. And here the idea is that you have a main repository with the latest version of the source code. So instead of working directly with the main repository, a contributor, so this is not the original author, it's a contributor, goes and forks the main repo. That means he gets a local repository that is independent of the original repository, but that's good because the contributor can here perform the changes and have his own version, his or her own version there, and then that's a clone, and this is independent of this repository. But at one point, if this changes, if the changes here done are relevant enough, and the contributor wants to share them to get into the main repository, what we call upstream, then he opens what is called a pull request. Like, look, here is the code I've done. Here are the changes. Please, if you want to integrate it. And here the thing is, that's very relevant because usually the community uses the software that is here in the main repository, and that's the one that is forked and so on. So, and once the changes come into the repository, they are it's the duty of the maintainers of the main repository to keep on maintaining that source code and so on. So that's a very important step. So in the sense that if you are not here, this is not a contributor but a company. If you want your changes to be part of the main repository, usually because that makes that the effort is then on the side of the original developers. It's not effort that you have to devote on yourself every time when there's a new version, seeing if you have to, if your changes have to be introduced and so on. No, you can't forget about that. So that's why it's important to open the pull request. It's like, here is my code, please have a look at it. And then what is done, usually it's that then there is a continuous integration tools, like Travis, that check if your changes don't break anything, because you have unit tests and other regression tests and so on. So it just passes all these checks. And if this is done, and this is usually done automatically, then you get to a peer review phase where human developers say, okay, look, this change looks good, but you should change this because of quality issues, because of standard development methods that we use here, like that use this type of writing, this style of guide that we have. If you think about Python, the indentation should be 4 blank spaces and not 2 and whatever, and then you get sometimes it doesn't get integrated into the source code at first, but you have to update the pull request, and it gets again to the check here from the continuous integration system, and it's peer reviewed again. And at one point, eventually, when the reviewers here, which are usually developers from the main repository, which is in this case, it's one of the main developers of the main repo, then it gets approved, and then it's merged into the main repository. And this is the integrator. That's how we call the main, or one of the main developers of the repository, of the main repository, and then it gets into the main repository. And as you see, this is now the way of development of most of the projects. At least if you go to GitHub, that's the way to go. If you go for larger projects, then they have a setup which is of course more complex, but this is here the essence. So for instance, if you go for OpenStack, it's the same here, just the continuous integration check. Sometimes it takes a couple of days, and then their peer review, it's not like it's approved just by one person. Here in the peer review, you have a community peer review that it requires you at least to have 2 positive reviews from core developers. So that's a status that you can get. And no negative review, because if not, you have to go the cycle and so on until it's approved and merged. And actually, this takes long. So just imagine, we've seen in some research that if you are a professional developer, then you get in around 12 12 changes every 6 months. So the traditional professional developer introduces 2 changes per month, which one might think is a low productivity, but that's because the changes are sometimes significant. They are not easy, and all the process takes time. And that's part of the quality, because if you peer review, that's not all the source code as it comes gets into the main repo. It has to work. That's the CI check, but it has also to be of high quality, and that's a little bit the idea. So the thing is still to have a community and to make things easy, because you can do this fork is something that you already know from GitHub. Making this fork is really inexpensive and really easy. So the thing is, if you want to contribute, then it's easy, and it's easy. Open a pull request is also something very easy. And here, that's the part here with the quality control that sometimes it's a little bit struggling, because especially in the, let's say, high specialized professional projects, then you have to have high quality software, and that's not that easy. But in other projects, you just see a bug, and you just you solve it, you create the pull request, and it gets accepted, and that's something very usual. So as you see, this is the way of implementing today many of Eric Raymond's ideas from the cathedral and the bazaar. And it may change in the near future, in the sense that tools come and go. So this is now the GitHub way of doing that, but before it was different. I mean, in Linux, they did it before all this. They did on the mailing list. So instead of a pull request, they sent the code directly to the Linux mailing list, and people were commenting. They didn't have CI checks. They were commenting. The peer review happened on the mailing list, and you saw mail threads, people commenting the source code, and then at one point it got updated, and at one point it got approved and integrated into Linux. So this was done not through there was Git here, but they were mailing some parts done on the mailing list and so on. Now with GitHub, we have a process where you can do that in one place. And when I say GitHub, it's GitLab and many other places that follow this pull request model with continuous integration, which is, as I say, that's the process that you see usually today. So that was it on my side. You have here some references to Eric Raymond's The Cathedral in the Bazaar, and to Nikolai Bezrukov, a second look at the Cathedral and the Bazaar. And well, as I say, that was on my side on the open source processes. I hope you have now a clearer picture of why they are this way and how the current model is and why it might change, but not in the fundamentals. It's make it easy for other people to contribute and still to have high quality of your software. That are the main ideas. I don't know if there are any questions. I'm happy always to have some interaction. So we still have a couple of minutes for questions. So feel free to open your mic, to use the chat. I have the chat in front of me. And make any question, comment, suggestion. If not, if I'm not wrong, I think we have then a break, which now it's almost it should be. Let me check. It's your time should be. Is it 1 o'clock? 9. Yeah, it's 1 o'clock almost, and we are starting then the next session in like 14 minutes. So it's at 1:10 at your 1:10 if I'm doing the maths correctly. So thanks for your attention again. and we meet. I'm writing this on the chat. We resume in 13 minutes. So we're then back. So let's take a small break, and we see each other in a couple of minutes. Thanks to you. we have now our session on open source software analytics. So I'm gonna again share my screen. And I'm putting a slideshow. So this is the session on software analytics. So I have to say, this is from my personal point of view, the session that I am most aware of, because I research in this field. I've the idea is summarized here. So if it is difficult to improve, if you cannot measure and track your improvement. So the motivation here is to understand software project data and what can be done with it. So one of the nice things of open source, and that's the consequence of the process that we have seen before, is that everything or almost everything is in the open and it is archived. When I say almost everything, is of course the conversations you have if you meet somebody at a conference. Those usually are not there in the in a repository or whatever, but all the rest is. I mean, you can see all source code, all the past versions of the source code, all bug issues, all bug fixes. The code review is made in the public. The mailing lists are in the public. So almost all communication channels, the IRC and so on. So nowadays, almost everything, besides tools like Slack, where people communicate synchronously, and there are some projects even that store the Slack conversation. So this comes also because I would say the communities are interested that everything that that they decide that it's in written form. That's in Apache. They always say that everything that is decided has to be put in written form so that it can be tracked back, and then it's important on the mailing list that it's stated. So here the motivation is, if we want to improve the software development process and we want to improve the project, so instead of having an opinion of what could be improved and what is wrong, what you can do is go and take the project data and have a look at it and make it in your benefit that the project data is out there and that it's open. So therefore, it's important to understand it, to see what can be done with it, and to see how can we use that that knowledge in our favor. And interesting enough, this has been a very research topic in the last 20 years. So there's a big community which is called the Mining Software Repositories community, because it's about mining software repositories in the wide sense, because we think that software is more than source code. Then you look at the mailing list and you try to understand what is happening there. And I will show that there are already some tools out there. So you can create, of course, your own scripts to retrieve the data and to clean the data and analyze the data. But there are some mature tools out there. So just in the vein of the cathedral and the bazaar, if there is something there that is already mature, then you reuse it. Don't start from scratch. And I will show some examples here in the not maybe in this first session, but we have a second session afterwards, which is more hands-on. And then I will show how you can gather public available data with a tool that is called Perceval. And you will see that it's easy, and you can do many things out of this. And the fourth point in the motivation is Perceval is really part of a big suite of tools which is called Grimoire Lab. And with Grimoire Lab, you could go and have a complete environment to analyze your project. So it's not only that you can retrieve the data, that is what Perceval does. It also has ways to show the data and to to manage and handle the data and so on, and it's ready. It provides you a dashboard, so it helps you in the decision taking. And this Grimoire Lab is a really very complete system, and you will see it has many parts, and I will show some examples. So that's here a little bit the motivation of the next 2 sessions in total, so that you understand what you can do with the process, with the project data, and how you can work with that. So one of the things that should make you understand that this is a necessity is that if you go to some development projects, they may be really large and complex. So this is a picture taken from one of the OpenStack summits, if I'm not wrong. So there's an OpenStack summit every 6 months, and there are thousands of developers going there. So the OpenStack community is built by many thousands of developers, and it has many projects, and it's very difficult to understand such a big community. There are many companies involved. There are many volunteer developers. Each of the companies has its own strategy. Each of the developers have their own situation and necessities and so on. So if you it's not like in a company where you actually pay them and you know how much time they devote to the project. Here you even don't know that information. So if you are, let's say, in charge of OpenStack, you're part of the community, and you are one of the leaders, and you want to know about OpenStack, then you might understand by looking at this picture that it's not easy to know about many things, and that the amount of information that you can retrieve is really large, so and complex, as we're saying. So and the other point is they are not only large and complex, they are dynamic, so it's a moving picture. And then you want to understand the project in its current state. You don't want to understand the project as it was 5 years ago. That doesn't solve your problems from today. So you want to understand how everything is going, and if everything is developing smoothly and today. So here the difficulty is it's difficult to track what's happening in real time. It's difficult to know if, for instance, if we look at the process before, just imagine, if we don't have enough code reviewers, then there is a bottleneck there, because people are submitting their patches and they're waiting for the code review to be, and the patch to be approved. And if this doesn't happen, then you have a problem, because there are contributors that are spending their time and efforts, and if they see that this time and effort doesn't make sense because nobody's there to review it and to integrate it into the source code, then they might disappear and no show up. And that's, as we now understand the cathedral and the bazaar, that's not good. We want to have a community, a happy community, that they contribute and that they contribute more in the future. And being on top of these things, when you have such a large audience, is not easy. You have many projects, you have many code reviews every day, and you don't know how long it takes, for instance, to get something reviewed, to get something merged, and that the community itself is on top of the things. So that's the track what is happening. The second thing is understand why it's happening. So just imagine, and that's again, code review is very human intensive. That's why it's always a good example. So just imagine you see people start complaining because they submit patches and they do not get reviewed, and that's the bottleneck. So you can track now what is happening, and the next thing is to understand what's happening. Is it because we need more people there? Is it because the patches aren't good? Is it because somebody in the code review is being too strict and then always sends the review, the patch back to the next review cycle, and then it takes long and so on. So it allows you at least to have a wider perspective and understand. And then it's difficult to react quickly. This all takes time, and if you have to talk to many people, then this takes time, and sometimes things might go unnoticed, which is bad. But if they get noticed, even that may take weeks. And in the meantime, your project is suffering. So that's bad. And of course, just imagine you do the first three parts. You know what's happening. There's a bottleneck in the code review process. You now understand what is going on. We need more developers here, and you can react. Then the last part is to see if these actions, if this reaction has been beneficial, and if it has worked. So you still have to look at the process and see, okay, we had a problem 5 months ago with the code review, and now it's solved because we can see now the metrics, and we see that the mean time to get reviewed is just in the a couple of hours, and before it was weeks. So we can evaluate the results. And that's all. These things are not easy to do. The good thing is, if data is available, and that's one of the things that is good from open source software, that data is usually available, then analytics may come to the rescue and help you. And that's what this session and then the next one is about. So we have data, we can look at the projects, we can see what is going wrong, we can discuss what we can do, and we can see, we can act in order to enhance, and then we can see if this enhancement give the results that we thought. So this is a continuous process that you have to do. So you have to figure out first your interest. What do I want? So I know in this example is if my interest is to have a smooth code review process, that once if somebody sends a patch, then it gets reviewed fast in matter of hours or even days, but very few days. And at the end, even after a review cycle and so on, that the code gets integrated in matters of very few days or 1 week into the source code. So you have there a goal, and that's your interest. Then you should find out the available data. Do I have data for this? No, then I have to look for the code review and so on. I have to define the key parameters. Time to first review, time to merge, number of reviews. Then you have to monitor, understand, detect deviations. Once you know the key parameters, you take the data, you download it, you analyze it, and then you see here there are some deviations here. That's what's happening there, and so on. Then you can correct and improve it, and finally you can track the results. So the way to go is measure, monitor, act, and as a continuous process, do it again: measure, monitor, act. And that's one of the things that we can do with the continuous process. So a case example here, I was talking about code review, but let's take another one. It's the activity. If you want to see, to measure the overall development activity, then the interest is activity. I want to have an active community. So if you remember, that was important, for instance, for all these assessment methods that we were talking on Wednesday. So we want to have activity there in the community. So the data is changes to code, tickets, because that's why we want to focus on. We could select other data, but at some point you have to say, okay, this is from all the possibilities, this is the data we want to look at. The parameters are number of commits and tickets closed. Because we decided as that. So that are the parameters. And for the monitoring, we use charts, numbers, and so on. So one possible observation is numbers are declining. As you see, if that's the observation, then the action is allocate more development effort and then track the results and see if activity is again rising. So again, we have this measure, monitor, act, measure, monitor, act, continuous process here in this case. So I will show some examples where this has been applied to real projects, so that you understand better how we can do that with the current tools and the current technology. So for activity size, look here, we have committing patches. So you can, you have the source there, the source code management system. You get the Git repository and you see how many patches have been committed and so on. If you want to see reports or comments on bugs, you go to the issue tracking system. So there are bug tracking systems. GitHub has one, but there are, for larger projects, there is Bugzilla and other bug tracking systems where you can get that data from. You can see the submission of patches and the revision process, and that's done in a code reviewing system. So that's the pull request on GitHub, and you have other systems that are used as well. And you can as well see messages, the exchange of messages, usually which are synchronous or asynchronous communication systems, like in the forum, in mailing lists, and whatever. So that's a way of measuring size and activity. And then you have this, you get all these parameters, and you can reflect for a period of time, and you can see the people who are active during that period. And of course, you can see how they have been evolving over time, and you can find then probably trends if they're rising or getting minor and so on. So here, one of the lessons that we have learned is that it's difficult to compare between projects because each project has its own nature. So what you can find in one project, it's difficult to move it and learn for the other project. But it's interesting to compare in project, in the sense that you can see from the history of the project and you can take actions. So that's something that we've found out with experience. We thought, like 20 years ago, we thought it would be easier to compare between projects, and we've seen that's not that easy. And here is an example of a dashboard that I'm gonna slightly introduce. The important thing is there are many facets. So we are talking about all this activity patterns. And if you see here, we have 3 rows. The first one is Git. The second one are issues. And the third one are pull requests. So here, as you see, we got always in the left column, we got numbers. And then we got activity, and we got other issues. So here you can see the number of commits in total, almost 50K, how many authors, and how large usually commits are. That's the median. So in the median, 2 files per commit. And then the median lines added per commit, and which is 9 lines added per commit, almost 10, and lines removed per commit in the median. So this gives you an idea of how big changes are, how many changes, how distributed. So one more than 1K authors. So this is a big project. And you see 50,000 commits and so on. And you see the commits over time for the project, and you see there are phases. Usually here, this is Christmas or vacation time. It's not always that the phases are that is like stable around. So and the same you can see here, the number of authors. So while here in commits over time, we can see that there are more commits, because of the area around 2015. We see that the number of authors. So this authors would be that somebody has sent at least 1 commit in 1 month. So it increases steadily. So probably this year is summer, and in the summer it's usually people go on vacation, or in the northern summer, and then there's less activity and so on. But you see that this is growing slightly. So this is a way of measuring your community. If you look at issues, then you can see how many bug reports we have here, 15,000, which is not bad. And how many reporters? Note here, we had 1K authors, and we have 3.5K reporters. So as you see, usually there is a factor of 3 to 10 between authors and reporters. It's easier not to go to the to the issue tracking system and put there a feature request or to submit a bug report, then to submit code. And then here it says the median time in days that these bugs are open. So it's 11 days in the median. So that means if you take if you group all the bugs, you put all the bugs in a line, so the one that is half of the way takes 11 days, and well, the number of assignees. So that's the number of developers that are assigned a bug. And then again here, we see the issues over time. So it's growing with its up and downs, but there's more area here, purple area at the end than at the beginning. And here you see the bugs when they were created, and you see the cycle. So there were lots of bugs created at the beginning, but then that's one thing things that you can see. And finally, the pull requests. So this is taken from GitHub, from a GitHub repository. Look how many pull requests. So this makes you an idea of the importance of the community. So we have almost 50K commits, 12K pull requests. So it's 1/4 that comes from pull requests. Look how many authors. 1,400. The median time open is less than 1 day. And this is the assignee for the pull request who has to review them and so on. Here there's only one reviewer. But look, in less than 1 day, the median time is less than 1 day. So usually if you submit a pull request, you got a fast response because it's in matters of 24 hours. Half of the pull requests are closed, and you see this has been growing here in the picture. Also at here the time open, and yet here it's interesting. Oh, that's the time open. I was thinking how many time open. So here this project has made a big has been a big success in lowering the time open. So you want to have your issues, if they're opened, you want to manage them. And at first the median, 15% shortest issue, so that's the median. The median was over 100 days. Let's say here 100 days time open, and then it has moved here to there's some peaks of 30 and so on, but they moved around 10, 20. So that's good. That meant here, if you see at the project, they had a problem here probably. And you can see the same with the pull requests. They were open here, time open, 15 days, 10 days. So this here, probably the development process was too small. If we look at these figures, we can find, okay, this is something that is not good. So we are not we are not, let's say, attending having good attention for the community. It's taking too long, and if people contribute and they see that this doesn't bring nothing, they won't come back. So that's bad for your project. So probably here they noted there is something wrong, and they took some action, because this is a project that was taking like example of here they decided something, probably here at the beginning, and then this is the result of looking at this. And you see sometimes they have peaks. This is probably because of the release cycle and so on, but now they've brought it to 10 days for time open for bug issues, and here for pull requests even under days. So that's of course good. This situation here on the right is much better than on the left, and that's important, especially because look again at this picture. If you don't have these measures, you don't know about these issues. So it's good to get that data and to see what this data tells you and what you can do. So let's go back. So here we have a different angle. So this is a different dashboard from a different project, and you see the information in different ways. Oh, sorry. Yes, here. So here you see the commit, authors, and so on. That's a different project from you see, but look, commits by date. You see this is growing in 3 years time. Look how much it has been growing from 1,500 to 6,000. So it's a 4 times increase. And here you see the project. So if you look for infrastructure, Nova, and so on, this is for OpenStack. It says here OpenStack, the Git activity and so on, and you see the number of commits of the different projects that you can see, and you can see the top authors. And look, Monty Taylor has almost 3,400 commits in 37 projects. So you can have a look at the top authors, and this is here very important. That's, remember the assessment. People want to, or the business models even. People want to show that they are the producers. That's a big business model, that they have the expertise. And here, what is done is, there's a way we will talk about that to assign developers to their employees, because we know that Monty Taylor works, for instance, for IBM. And then we assign the commits to IBM and so on. And then if you look at this, then we have a classification of the top organizations. And that's here. You can see that in OpenStack Red Hat, which is one of the big companies that we were talking the other way, is first in OpenStack in number of commits, and then comes HP, Mirantis, Rackspace, IBM, and then we have unknown because there are 6,000 commits which we couldn't assign to a company, whose authors we couldn't assign. So the commits belong to authors, but these authors we couldn't assign a company, so we don't know. And there's Google and Cisco. They are as well in the top. If you look at the active authors over time, this has increased from 100 to 1,000. So it's an order of magnitude. And just think, having 1,000 active developers, what this is for a project and how you manage it. That's where the data is very important. That's why projects as large as OpenStack, they want to have this dashboard. So this, if you see, it's Bitergia Analytics. That's a spin-off company that came out of our lab. So they offer as a service this type of dashboards. The interesting thing is all the tools are open source, so you can do this on your own, and you can take the tools and have a dashboard for your development project. When big companies want to be supported, and that's what Bitergia does. And then here there is an interesting thing is you can see the time zone of the commits. Usually when you commit, you have metadata, and here you can see from the metadata the time zone, and you can see here that the most active regions are. Now this is California. Well, this is California in the winter time, California in the summertime, and so on. That's the East Coast. So you see here there is a peak in California. This is here Portugal and the UK, and this is mid Europe and so on. And somewhere here you have let's see, because it's India would be somewhere like here. It's 8 hours UTC plus 8. I don't think so. So there's not much development, because I think India would be 6. It would be here. So there's not much development going on in India, for instance. You can see that. So that's maybe that's a fact here from the commit time, and that would mean that, for instance, there is a lot to grow in India. So I know. Interesting. So And here the fact is development is more than developers, and this is both for open source and also inner sourcing. So developers, they are all around the repositories, but then you have contributors. We have seen issue tracking. If you look here, that's why we have 3,500 reporters and 1,000 authors. These are developers, but these are contributors. They don't have to develop, so they appear there in issue tracking and synchronous communication. You have users. Usually in asynchronous communication, you find the users and so on, and you have the ecosystem, which is more difficult to trust beyond the active users. So there's a need to track identities in different data sources, because just imagine you have you have your identity in the commit messages and your identity in the mailing list, which is an email address, and the other one is just a nickname, and then the thing is here to merge. So, and you can take data at many different levels. So here at the repository level, at the class of repository level, at the project level, at the global level. So you can have many different types of activity involved, and you can see it over time, as you see here. So, and you can do things like this to measure your community. So this is not only about technical things, about commits and source code and so on. So you can see how your community is aging, and if you are getting newcomers in, and people that abandon are that new people are joining, and that that you are still growing to some extent. So here, what you see is a chart where you can see how this is here how old the developers are when they appear to have their first contribution. So 0 years, they have done it this year, and you can see how many of them still are active, and how many of them are they disappeared, and and so on. And then you can measure. You can see here that how you know that here in this project, as you see, you have developers, because this is source code. They are active for 2 years, and then they start to to leave and so on, and that's here the same. Or at least maybe it's not to leave, because maybe the project is just 5 years old and these are the new ones, but you see this is a younger generation of developers, and the same happens with ticket participants. So you can have this type of information. We were talking before about time zone analysis and so on. This is very interesting for you guys if you look at India and you want to see if the project has any activity from India, and what type of projects are more interesting, let's say more local to India, and where the interest lies. For instance, this is Elasticsearch, and if you look at Elasticsearch authors by time zone and commits by time zone, you see here there is not much Elasticsearch development going on in India, and it's more mainly, as we see here, commits. They come mainly from California and from Europe. So this is a way of looking at where the local community of the projects are. And that's of course not very interesting. If you want, you want to see, you go there and see. If I want to know about Elasticsearch and I want to do a conference in India about Elasticsearch, then there is way to go. First, we need to set up a community, and probably it's different when the community is large than when it's small. When you start, then probably here, if you see like this, that's what community managers tell us. This is again, I mean, for Elasticsearch, then we would say, okay, here in India, we would have to do more tutorials and more showing the technology and what you can do with Elasticsearch and grow the community. While here, it's more development, and then you can offer conferences and all those things. So that's the type of information that this type of graphs provide you. And of course, you can put them in a map and see, look, here we have some No, from India. It's no for this is in general from GitHub profiles. So we have taken many GitHub repositories and seen where they come from. No, and you see the larger the circle, the more developers there are, and we've placed them on the map here. India is better located. No, that's the information. Punjab here is maybe not that much evolved. That's a thing that you could change, and hopefully can change in the future. Not only because, of course, of this course, but because of your involvement and your activities and so on. And then, well, you have affiliation, which is, as I've said before, very interesting. If you have a project where many companies join, they want to show the activity they have, and they want to be the leader in that because that gives them a way forward. So you can do things. This is also very interesting. There is the Apache Pony factor. The Pony factor shows the diversity of a project in terms of division of labor among committers in a project. So there's always the problem that one committer does everything, and then this committer leaves. And what do we do then? It's difficult to hand over to proceed with the maintenance. So the Pony factor is demanded by the lowest number of committers whose total contributions constitute the majority of the code base. So the 50% of the contributions. How many committers do we have? So that's a very known factor. It's called the Apache Pony factor from the Apache Software Foundation project. So they want to have distributed effort, and that if some it's sort of the bus factor, that if the developer if your company's in a bus and you get an accident, and the people are no longer available, what do we do? And because of this, the Bidjarja people have done the elephant factor, which is something similar. Here the elephant factor shows the diversity of a project in terms of division of labor among companies, not individuals. So they assign developers affiliated to those companies. And here the elephant factor is the lowest number of companies whose total contribution in commits by their employees constitutes the majority of the commits. So we can see here for some projects, this is data from 2016. Here they've looked at some very big industrial projects, and they measure the Pony factor and the elephant factor. Just think, Pony factor is for individuals, elephant factor is for companies. And you see that 50% of the code of OpenNebula, of the commits of OpenNebula have been done by 4 developers. But these 4 developers belong to the same company, so the elephant factor is just 1. So this changes, as you see here, for OpenStack, we had 6 companies providing that, and the Pony factor is over 100. So this is to some extent a measure of a healthy community when you have distributed effort and so on. And here mostly, if you see many of the industrial projects, they have an elephant factor. Even if the Pony factor is big, they have an elephant factor of just 1, and that might be a problem because the company says we're not interested in this project, and we leave, and then you lose this company, which is responsible for more than 50% of the project, and then that might be a problem. Another important thing, and I'm sure here in the audience, I will find much interest on this, is we can study gender and how much women contribute to it. As I was talking on Wednesday about software developers, we know that the contribution of women lies between 5 and 10%, and we can get the commits. We can look at the author names, and there is software that tells you, look, Gregorio, like my name, is a male name, so we know, and if we go for a female name, then we assign it to female. If we look for Vanessa, then that's a female name, we assign it to female. And then of course we have problems if a name like Andrea comes, because Andrea in Germany it's a female name, but in Italy it's a male name, and then we have to see if we have geographical information to assign it. And sometimes I have to say, when we have done this, we have lots of problems with Asian names, with the Chinese and Indian names, because we are not that much used to Chinese and Indian names in Europe. They have different rules. Here in Spain, if it ends with an O, it's a male name, and A, it's a female name. We provide many facilities. That's not the case with Indian names. And then we had help when doing this research. We had help from some Asian colleagues. And then here what we've seen is commits by women are 6.8%. This is for the Linux kernel. We studied it for 1 year. And now from November 2015 to October 2016, this was by the Linux Foundation. They hired Bitergia for doing this. And if you look at developers, authors, then almost 10% were women. So there were 10% women, and the share of contribution was 7%. So we can measure the gender gap. I will have some examples afterwards. So if that's what I wanted to talk about in this first session about software analytics. I hope you have seen, okay, because of the open development process, there is a myriad of data out there. So let's take advantage of the data that is out there and use it in our own benefit. And this is especially important when companies come in and they want to see if the money invested and the people they invest in the project, if they're used the right form. Usually they are professionals, so you can tell them where it's going. And if they're not professionals, you can see how healthy your community is. If there's gender diversity, the elephant factor, the pony factor, and so on. So I hope you have seen we can do that, and that's a good thing to do. Because after the break we're having now, if I'm not mistaken, we have now 20 minutes of break. So after this 20 minutes of break, we are gonna start to look at more hands-on with the data sources in Perceval and how to retrieve it and what we can do with it. And I will show you a place where you can create the dashboards very easily through a web interface, and you can play a little bit around with with projects that you like. For instance, yesterday's humanitarian software projects, and you can analyze them and see. Even you can see if there is a time zone analysis, where they come from, where the developers come from, and so on. So as always, I'm happy now to take questions and suggestions. Let me stop sharing. Just open your mic, and if not, then we can have this longer break. I know that it's should be lunchtime over there in India, so we will have time for a sandwich and some drink, and then we resume in 20 minutes. So no feedback. So if there's, yep. Okay, so I see just thank yous, which I appreciate. And well, let's do that. So we start again in 23 minutes, which is 20 past. So now if I do the math correctly, it should be 2, and then it's almost 2 at least, and we should start 20 past 2. Is my math correctly? Yes, should be. So yeah, fantastic. Thanks. So we are starting then 20 past 2, and then we will have, yeah, thanks in there, deep thanks, Dr. Kuliet. So we're starting 20 past 2. So thanks for attending this session. I hope you attend the next one, which is more hands-on, and you will see how to do all these things that I've been showing here with the charts and so on. I hope you find it interesting. So take a break, recharge your energy, and we see again in a little bit more than 20 minutes. our course on free open source software. In this session, I want to show you hands-on how we can do the software analytics part. So I hope after the previous session, you are already motivated about how to use the data sources that we have from free open source software projects and how to use them in a beneficial way. So now the question here is to talk about the different data sources that exist and how to retrieve the data and how to make something valuable out of the data. The point is there are lots of data sources used in open source software development. And here's an example of them. You have from GitLab, Bitbucket, GitHub, older versions of Git in general, older versions like CVS, Subversion, and so on. Usually these are source code management systems where the development process is a big part of the project. So, and then we have those places where we have the bugs. That we have Bugzilla, we have GitHub, we have Redmine, Jira, and other places. And that's so there are different tools that can be used for this. And then we have other. Beyond this too, we have other. This is like Mail for mailing list, IRC, Meetup, Stack Overflow for the Q&A discourse, and even wikis and so on. So there is a myriad of tools where there is data on the projects. So if here they are again, for source code management, we have all this. For issue tracking system, we have all of those. For code review, there's mailing list. Linux still does the code review on the mailing list, but there is Gerrit. There's the pull request system of GitHub. GitLab calls it merge request. That's what GNOME uses, and even in Jira and Bugzilla you can do the code review. And then there's asynchronous communication. Mailing list is a typical thing, but Google Groups, the mailing list archivers, and fora out there, and so on. So, and there's synchronous communication. The most traditional ones is IRC or Slack newly, and they're not maybe always text based. Like there might be video conferences. And in this kind of environments for the synchronous communication, in many cases, we don't get access to the archives, even if they exist. And there's, of course, privacy concerns. It's not the same that you analyze a mailing list where the authors know this is public, than for a personal conversation more on the IRC. And actually, it's more difficult here to track identities because it's not as standardized as in other places where you have usually the same identity. So there's a tool here which is called Perceval. But with the idea, let me check here. Here we go for GitHub, Perceval. This is the GitHub repository. I'm going to make this a little bit larger so that you can see it. So Perceval is a tool that allows to retrieve and gather data from software repositories. So it's one tool, but you have, with this tool, you can query and retrieve the data from many different repositories. Look, the list it's over 20 different ones. So you can get from GitHub, just lots of things, just Git, and many of the things. Media wiki for wikis, Redmine. So even if you have Telegram, Twitter, and so on. So the idea of this tool is it gives a simplified interface to access all this, all the data from these sources. So you have only to learn one interface, which is very similar for all of them. It's not always the same because each tool, its data source here has its peculiarities, But the idea is to do it the same. No, and here you see the installation. No, we'll talk about the installations. I mean, there is a pip package, so it's easy to install, and they are Docker available packages, and you can install it from source code. So I can show here some examples. For instance, let's go here for if you would like to analyze Git. Look, then you say several. Then the second parameter is what we call the backend, which is the source of the data, and then you have to provide, depending on this parameter, you have to provide here, for instance, an URL, and you can provide optional parameters. For instance, what this does is it analyzes this Git repository, and not for its whole history, but just since 2016. And that's a way of doing an analysis of Git. Just imagine we want to analyze GitHub, and this gets, look here in GitHub. For GitHub, you provide the name of the organization or of the individual, then the repository, and then you have optional parameters, again from 2016. And then it gets usually issues, pull requests, and repository specific data. But you could say, no, look, I want to GitHub, but only the issues for this project. No, in Elastic, the repository log dash, and then you only get the issues of that project. And if you go for something different, for instance, for Jira, which is a backtracking system, you get here Perceval Jira. You say here is the URL, and you want just for this project, and again you can put from which date. As you see, once you know how Perceval works, it's always pretty similar, which is good, for mboxes, MediaWiki, and so on. So the point is, look if there is a backend here for the data source we're trying to see, and for the most popular tools used, there is a backend, and then you can use Perceval on it. So I've got in the slides here some information on how you can install Perceval. Just note that here this information, what it does, it creates a virtual environment, which I've been labeling GL, and then we activate this virtual environment. So we create a virtual environment so that it doesn't interfere with the rest of packages that you have installed on your machine. And once this virtual environment is created, you can install Perceval in it, and it gets all its dependencies and so on. And then you can proceed. For instance, here, this should be a one-liner, but it doesn't fit into the slide. So this is just to analyze Percevals on Git repository. No, Perceval backend is Git, and this is the URL. Or if you would like to analyze the GitHub, not only the Git, but also all the GitHub, it's the issues and all the other information, you should write it like this, and then you have to provide in this way, no cows and Grimoire Perceval. And there's a tutorial there about telling this. So I have it already installed on my machine. So what I'm gonna do is I'm going to write this information here in the chat, because this takes this may take some time and so on. So you can if you open a terminal, you can do that on your own. Or let's do that. I will do everything on my own. Let's try that. So you see, this is I'm gonna go here to a different profile so that you see it larger. So this is best. So I'm gonna go here to temp, and I'm gonna create this Python virtual environment. So virtual environment. So I create the GL Python virtual environment. Then I activate activate. So I'm there in the virtual environment. See, and then pip reinstall Perceval. So that's it does, as you see, it collects all the dependencies that it requires, and we have now Perceval installed here in our virtual environment. I'm gonna go to the top, Perceval, and look, if you do Perceval, then you get the information that you've already seen. This is you have seen that before from its GitHub page. And what we are going to do is let's run Perceval on Git, and then we know it's HTTPS probably github.com house grimoire lab Perceval, and then from date, and then let's see how it's done. I have to look here. From date, let's put it's with a space, and then 20/01/01. So we will look all those commits that have been done to Perceval since January 2020. And if you do this, as you see, that was too fast. There are many commits. So what I wanted to show is that if you do that, the output you get is something like this. And this is a JSON format. So JSON is a very well flexible format, and you do with this JSON format. The good thing is it's text. Let me do it again. So I go here. This is the last line, and then I will put here Perceval Git. So what I'm doing here is I'm redirecting the output to this file. So does this. Look what it says. It says Perceval is on the quest fetching commits from January 2020 until January to next century almost. And then in total, 217 commits have been fetched. And you hear the min date, the max date, and then you have here some things. And then that's, as you see, it has taken matters of less than 1 second, a little bit more than half a second. I mean, this was not a big repository, but the nice thing is I will open the JSON file, and you got here the JSON file. And let me make this a little bit larger. Preferences and editor. No, here. Blah 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 blah. I think with 20 it should be better. That should be enough. No, now I think you can see it. So this is JSON, and JSON can be imported and retrieved and read by humans quite easily. Look here, it's like a sort of dictionary. If you know about data structures, it's sort of dictionary. It says, look, here it tells a little bit about which backend, Perceval backend would have used Git, which version of the backend commits, and if we have any classified fields, we didn't do anything about that. And then here we see data. That's for each commit, I guess. Let's see. This data, author, date, commit date, and so on. So what we can see here from data is the data that we have for each commit. So each commit here is a dictionary, and then here we have the data of the commit. The author name, it's Valerio who did this, February 3rd, 2020. And you see again this is the author, this is the committer, which might be different, the integrator. The commit date is this one, and signed by Valerio. This is the hash of the commit. These are the involved files. So backend score groups IO has been modified. 12 lines have been added, and 4 lines have been removed. Then this file has also been modified. 39 lines have been added, and 0 has been removed. And this is the commit message. Says group IO fetch messages after given date. This code allows to blah 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 blah. And this is the parent commit. What you can see is is a big hash. And then you have again here the origin. So this is metadata, the Percival version, search fields, attack, timestamp, dated on, and that was it for this commit. And as you see, this is the next commit. And again, git, blah, blah, blah. And this you can see all the meta information for the commits in JSON format. And as I say this, we can analyze it like this, or there are many packages. There's a JSON package in Python where you can get it and you can analyze this data automatically and do something out of it. So this is really a convenient way of working with that. So the nice thing of JSON, because you can, some people say, no, why not in SQL format? You can then transform, extract here the first let's say before extracting, identify the relevant information for you, and then extract it easily from the JSON and move it to an SQL database. The thing here is with JSON, you have one way of having a format that is universal for all data sources. Because if you look, the other thing that we could do is we could say Percival GitHub, and then cows for Grimoire Lab Percival. Just notice now we are not looking for Git, it's for GitHub. And then from date, and again, let's look past 2 years and a little bit more. And if I didn't do it wrong, then, okay. As you see, is JSON. Let's do it again, because what I would like to do is to have the output. Let's go to the top. I lost the top. I see I lost it, so let's put it again. So Percival, we run it on GitHub. Cows, no, that's an organization, GitHub organization. This is the repository, Grimoire Lab Percival, and then we just look since 2020. It does require sometimes authentication. I will come to it now. So and here Percival GitHub JSON. So I'm before it was Percival Git, now GitHub, so a different file. Then Percival is on his quest, and this will take a little bit longer because, as Dr. Kuljit correctly asked, is if you don't have authentication, the rate limit gets exhausted very fast. If you have authentication, then you could retrieve, make up to a certain number of requests per hour. I think it's 5,000 requests per hour. If not, it's just 100 requests per hour, something like that. So here we get the rate limit exhausted. So basically, Percival GitHub help. So here I see we could use, instead of redirecting, we could use -o for the out file. Here you can look in GitHub, and there's a place where you can add your token. I won't do that because then I have to show mine, but you can go to your GitHub user interface, and you will see token is one of the things that you have in your preferences. You can ask for one token, and then this token gets with -t. So actually you would run this something like this. -t. No, this is my token. This is something that you have to retrieve from GitHub, and then it automatically retrieves this 5,000 hits per hour, or whatever rate there is now, and then you can get. If not, you just can get the maximum until the rate is exceeded. So here, if we look, I outputted it to a file, which is a Percival GitHub JSON. What I wanted to show is the JSON output is always it, but it changes. Here, the backend name is GitHub. Before it was Git, as you see. This is for Git. And backend version is 0.27. And then you have here an issue. And you have metadata of this issue. The assignee is null member, and here's the body of the issue. That's the text that you see in this issue. And it was closed the 10th of January, and there was one comment. And this is the comment of and how many plus ones and how many minus ones, if there are any reactions and what type of reactions and so on. And I see lots of data. This is still data on the comment, the avatars and so on, blah, blah. Comment URL. So if you look, this is the issue. So where are we? Well, this is actually the comment as you get it in again in the API. And then you can see the same information that you get through the interface. Let me see, because this is the API. This is the HTML. This is the issue. So as you see, this is an issue, and this is what we got. And there was one comment, as you see. And you got this was sent probably by somebody, and it's Valerio who commented on it, and you all this information, and when it was closed on January 10th, and you get this information. All this information is here with even the avatar and all these things. And as you see, it's lots of meta information, and then you get here the next issue, and then the information. If you look at this is this issue. You must use with source piece and so on. This is you get all this, what you see, you got it here. But this interface, the JSON interface is as you see, as it is structured, you can then get it with the JSON libraries very, very easily. So here you have issues. You should have other. Let's see what other types of categories. If I look for category, and if I look for category, this is an issue. This is an issue. So we only have issues. No other category now here. So no other category. But there are, as you know, there might be other things when you retrieve the GitHub API. So I've been only able to retrieve, without exceeding my limit, like 8 issues in this. By using here Perceval. So if you have the token, as we were talking before, if you have here the token, which I don't remember where I have, then you can use it more. So as you see, this is a quite easy interface to use. Once you get used to that, remember, we go here to this one, then that's fantastic, because depending, there are lots of backends, and these are the most popular. So if you want to retrieve your data, that's a nice way to do that, and that's a good starting point to use Perceval and to have your raw data there, and then you can do whatever you want with it. And you see here Git, and this is GitHub. These are the examples we have shown. So this is easy to retrieve. This is from the command line what we've shown, but you can use Perceval as well as a Python module, as if it would be a library, and this is the way to use it. So if you click, this is a Python script, and then you can use here, for instance, this is Perceval backend core Git. So this is the Git backend. You provide the repo URL, the directory in your home computer, and then this gets the repository, and then you can fetch and do a for loop, and for each commit prints its data. Look, what you fetch is really JSON, so you got to commit data commit. So if we go here, you would get come here, commit data commit. So here you would get this information from this commit, and from the other information the other commit, and so on. So you would get the information of the authors if you do that using this as a library. So you don't have to do it through the command line. You could also import it as a module, for a Python module, which is a nice feature. And here there's a more complete example. I put it in the slide, so once I share with you the slides, you can see what it does. But it's the same. I mean, it's just it gets arguments to do this the same, no? And then you can pass the, no, here they were hard coded, the repo URL and repo dir, and here you can get them through the command line, and the rest is quite similar. No, it just prints the commit, data commit, and counts how many, and at the end it says so many commits. No, we have analyzed so many commits. So this is a slightly more complete example where you can use that for any, with any, and by default it uses temp Perceval Git if it's not defined, and here is the one you define. So that's one way you use the arguments from the command line. So that's the exercise I would suggest that you do. So download and install Perceval as I've done before. Look at the available backends, run it on a data source from an open source project, and tell how many items, commits, messages, questions you have found. That's what we have done a little bit. So I would like to show now the whole picture, because I've been saying that Perceval is part of a larger tool set. And the larger tool set creates at the end this dashboards. And as you see, Perceval is just the first part, which is usually the most used part by others, which is just retrieving the data. Once you have the data in such a format, you have to extract it in different ways and create a dashboard out of it. And that's what Grimoire Lab does. Grimoire Lab is a complete system. It's a little bit more, or definitely more complex, because if you want to do this, you also want that the data gets updated on the fly, in the sense that you have the data for last month and now you want to update it for this month, and then it retrieves only the differential part, only the activity that happened during this month, and then you get your dashboard updated. And that's usually companies and more serious institutions are interested in Grimoire Lab. For smaller things, Perceval is enough. So this is a Grimoire Lab. The motto is software development analytics with free open source software. It's a Chaos project. Chaos is a project from the Linux Foundation, which looks for analytics. They have seen that. They have seen similar presentations as you have been seeing in the previous session about software analytics, and they know this is a good idea. We need to be on top of the projects and to know what is happening. So we provide tools that help in this endeavor. And here you can see the repository. Grimoire Lab is, well, let's see, the repository in GitHub. And here is the whole picture of how this works. And I'm gonna, as you see, there are here lots of interactions. So I'm gonna try to introduce you to the Grimoire world here, and to show what is each component doing and why you might think to use it sometimes in the future. So we've been talking about Perceval. So there's different steps here, which are the boxes. So first there is extraction. You extract the data and you download it to local, and you have it in JSON format. And then you have to process it, which means you take the data and you do something with it. So you filter it, you merge the data. I will talk about specific mergers. You clean it, etc., etc. And this is when you process the data. Part of it is, a very important part of it, is to identify the identities, to merge them. That means if you take Perceval, now we've shown Git and GitHub, but usually you are interested, if you're a project in many different data sources, that all of them belonging to the same project. And then the thing here is, in all of them, I might appear in a different way. In a mailing list, I appear with my email address. In GitHub, in the issue tracking system, I appear with my GitHub username. In the commit systems, I appear with my commit name and commit email, but maybe I use there a different commit email. So, and I might have different emails, but I'm the same person. I'm the same identity. So here there is a module to do that. And part of the identities merger is as well that I myself have these different nicknames and email addresses and so on in different sources. But in addition, I'm an employee of that company. So any commit I do, you can specify that it's assigned to that company. And it gets more difficult because people move around a lot in several, in some projects. So this affiliation information has to be updated. So I've been part, let's say, of Red Hat until 2017. Then I moved to Rackspace, and I was there 2 years. And then I moved to IBM, and I've been there 1 year, and so on. So then this information has to be there, and has to be somehow go and be merged conveniently, because you have to assign the commits. When I was at IBM, they belong to IBM. I mean, or at least they add to IBM's commit and not to Rackspace and so on. And that's the identities merger. So here, that's the part of the processor. The processor, this is important enough so that the processor uses external identity merger tools. So that is part of the processing that is done here. And this, you have indexes, that's the output of here, which are enriched. And these indexes are for Elasticsearch. And then the visualization part comes, which is, you can have the visualization, the output might be in a browser, a dashboard, as we have seen, and we will see shortly how to use that. Or you could have a document which is thought to be printed, a PDF document or whatever. So here you in the browser, in the dashboard, you request some interactivity. We will see that shortly. Here it's something that you print and you have that done. There are different types of visualization. And all this together should be configured. So if you see, for all these steps, there is one or more tools. So for the extraction, we have seen Perceval. And extracting one thing is easy, but when you have to extract from many different data sources, and especially you want to do it on a continuous basis, in the sense that your dashboard is always up to date, then that requires major engineering. And that's where Author comes in. So Author, what it does is it calls Perceval on the data sources, and it calls it on a regular basis, so that it's, for instance, every month, so that you get the data updated every month or every day. So you have to dashboards, the final dashboards are updated for every day. So that's Author, who has the knowledge to call Perceval, who's very good at retrieving. And then you got this item batches. The processor is called Grimoire Elk, and this makes use of Sorting Hat, which is based on a database of identities, which you can, this is done manually. And also there's some software here, because if I'm Gregorio Robles, then probably my email address is gregorio.robles at something, or things like that. It uses some heuristics that have been that come from the research literature, and then you can build this identities database semi-automatically, but sometimes there's some manual work there. And the same happens with the assignment to companies. If I'm at IBM.com, then probably I'm an IBM employee. And this is what Sorting Hat does. Sorting Hat, it merges the identities and provides them to the processor. And then we've got, this is enriched with, the indexes are enriched, and we got here different tools to have the output as a document or as a browser. Keybitter, sigils, or the manuscripts, depending on the type of output. And the configuration program is called Mordred. So that's when you want to have everything on one server and configure everything. So you could do it on the tool basis, but Mordred provides you an umbrella configuration package. And you can then, of course, do this on a Docker image and export it. So as you see, this is something that is not easy at once. There are many tools. It requires some administration work and so on. And of course, at the end, you get browser and so on, but the effort to invest is very large. So and that's what I've been talking here in short. So the thing is, I'm going to show some scenarios, and then there is a way of doing, of having all this or almost all of this without having to install it through a web interface, which is what I'm going to show also to you next. So just think about, these are different scenarios that we have. So we may want a JSON dump of a single repo. That's what we've done here, what I've shown. But maybe you want a database dump of a collection of repositories. So you can do that also with the database with unified identities. You can have visualization in an interactive dashboard. You can generate reports, or you can have dynamic reports, for instance, in a Pandas notebook. So all this is supported in some of the other ways. So this is very, very flexible. I think you have here more information about all these elements and so on. I think they are very much into detail, and I leave them here when I share the slides. If you want, you can work on them. Then there's one component which isn't here, which is now heavily under development, because if you look at the data sources, and that's important, if you look at all these data sources, what they do is actually they don't look, or let's say what they don't do by now is there is no backend for source code analysis. All these things, they provide metadata. Look at here, this is really metadata activity. And that happens with all these backends. And there is now a new backend which is still under development, and that's the one we show here, which is called GRAL, and it has 6 sub backends, which gathers data about code complexity, class dependencies, code quality, security vulnerabilities, license and copyright information, and code language distribution. So with GRAL, what it does is it's a new backend that is now currently under development, and it gets the source code and it analyzes it using this backends that GRAL has. So this is for source code analysis, because if you look in the stable version, the one that you see on the web page, we don't have any mean or any backend that analyzes the source code. And this is interesting because many people have asked about this. So therefore, it's GRAL, and you see here how it's going. It's actually now a standalone tool. It is based on Perceval, but here you can see how to use it. If you're interested in this, have a look at this, and it retrieves the same data. I mean, the data also in a JSON format. It doesn't change much. So let me show a couple of examples of what you can do with Grimoire. I have to say this is case studies 2, because case studies 1 I already showed in the motivational part. So all this analysis at the end have been done with Grimoire Lab. So these are just more examples. So and here for performance. So this is just easy. Here you see number of issues. So the idea is you do it with Perceval, you get the JSON file, and then, I mean, if you use the rest of machinery, you could get this graph, or only using Perceval and from the JSON obtaining this graph should be difficult. And you see, this is a backlog of open issues, issues that when they were opened, and how this evolves over time. So you can have here efficiency closing tickets. So this is closed to open tickets per quarter. So you see this is a quarter, and you see how many closed tickets of open tickets. And you see it's all here around 0.6. So you could do this kind of things. You could provide this information in a different form. So here it's very interesting. Look, at one point, opened, and closed. So there was a peak here. So probably sometime here in 2013, they said, okay, so we have to close those many bugs that we have here. So we had a peak here, and then the project did that. So time to merge is something also very interesting. Look here, the median and the mean. So how much does it take from the first pull request until the the code is merged into the repository. And if you look here, this is data from a real project. No, and the median is maybe the most relevant here. You may see it grows from 2 to 15, and then it goes up and down and so on. So this kind of things you can do and are very interesting. They know here the review time to merge per month, and this is to the 95 percentile. So this is the median would be here. You see, it's very, but if you look at almost all, it takes 150 days. No, this is here and the versions per review. How many versions do we have per review? Look. Here in the mean there are 1 or 2, but there are some patches that need up to 20 versions. No, in the 95 percentile they need up to 10, and here even more. And these are kind of things. So if you here, for instance, if you do for OpenStack, you see here the tools that they use. And here the story design, the tickets, the code review they use, the automated testing, and so on. And then you can analyze all these backends and get complete information. So interesting information that you also can get is for the Linux kernel. You can see how old the code is, years since last commit. And look this is by files. If you have a look at it here, it's most of the files have been changed in the last year, which is interesting. No, half of them. I think if you sum up is half of them, and then you see. So there are very few files that haven't been touched for 14 years or 13 years. And this was 2016, so there are many files that have been untouched from 2002, which is interesting. So you see, there's a lot of maintenance effort coming here. We spoke when we were talking about the open source business models, then we were saying development is only one part. 80% of the effort goes into maintenance. And you can this shows that this is true. Look, files have been touched very recently, and then that's important. And here we have the lines. Before we got at the file level. But here we got the lines, because you could say, look, yeah, I understand, but you make a modification just in the copyright notice, and then you have a modification in the file. That's cheating, to some extent. That is not that the file has to be maintained. Okay, I buy you that argument. So let's look at the line level, and at the line level we got here. Here we got there are lines that are almost 23 years old, but there are very few. If you look here again, the maintenance effort. I think it was the last 3 years. In the last 3 years, half of the code lines were touched. Just imagine something which is a multi-million line project. The lines get touched every. They are like 3 years young. Every year, there are almost 2 million lines of code are touched in the Linux kernel. 2 million lines of code. Just imagine the magnitude that we're talking about, and that's what remains. But here, so you can see here the age of the lines, which is very interesting. And then the first remaining commit. If we can file files, and when they were committed for the first time, and as you see here again, still there's lots of activity in the Linux kernel that is quite recently. So many files have been added in the last years. So that's if you think about this is impressive. And how much effort goes into the Linux kernel. And you can do that for many other things. So here this data about authorship, years since authorship, and a number of lines. Here wireless, USB, IRD, let me blah clockwise. These are modules of Linux, and I see wireless, USB, IRDA, and there's a comma here missing. This is Ethernet, and you can see that, for instance, Ethernet is older. So there's not much development going on in Ethernet, but there's a lot on IRDA and then USB. Look, and it's different from wireless. So you can do that at the submodule level. And for instance, here for different parts of the Linux kernel, you can see how they are evolving, and you can see, oh, this is IRDA is now a hot topic in development, while wireless, see the number of changes in lines is much lower. So you can identify those parts where there is more or less development. So, and now comes to a more, let's say, nicer part, because probably you see, you've seen, okay, I understand that there are lots of data sources out there. I understand that we can get metrics out of them. I see how to retrieve them easily with Perceval. I've seen that using the whole Grimoire Lab system is somewhat complex because it requires many components. So let's see at Cauldron, which solves the last issue. So Cauldron is a place where you can create your own dashboard very easily. It's a bit limited because it's not easy to Cauldron.io. Oh, and then it's as I say, it doesn't provide all the functionality, but you could analyze any project you would like. So it says here, start analyzing, and then you put here a report name. So the GIAN, GIAN thing, and then we can put here what data sources we want to add. We want to add, for instance, Git. You see, these are the backends that we have. They are not the full list. They are not the 20 something. They are less, but that's at least Git. So which Git repository do we want? Yesterday, Dr. Kuljic showed some humanitarian open source system. So any I see here, I missed one question. What is the unit of time here? I'm sorry, Dr. Kuliat, I saw right now the question. I get too excited when talking about this, and then I wasn't aware of the chat. So maybe afterwards we can go back to that graph and talk about that. So I was talking about yesterday. You showed some GitHub example of a humanitarian open source system. Could you share the name with us, and then we use this for the analysis, and then let's see what we can find. What's about time to merge pull requests? It was in days, I think. Let's see. So this is about the Linux kernel, time to open. So it says here days. So probably it's to review over time. So this is days, and this is number of iterations. And review time over time. So this is number of iterations. This is days, and here number of issues. So it should be days. Open MR. Okay, let's go to that. So I'm here in Cauldron. So open MRS. And and then GitHub. So that's one system yesterday that was presented here. So we're going to go to the core repository. So we have here this repository, and we saw there's some activity, and I think this one's the repository where some of you said, 10 minutes ago there was the last commit. So this is the repo. So let's go and let's see. We add this, and we want to analyze Git, and let's put GitHub. I don't know we need authorization there. It's about the token and so on. So now not that good. So let's stay. Let's start with the open MRS, and then you can do on your own the other one, or if you don't have time here. So okay, uses cookies and so on. So let's create there isn't any data. Oh, we have to add it. Okay, add it. You see, that was easy. We add a Git repository. You could add GitHub, but then you need the token and so on. You can use it for GitLab, Meetup, for GNOME and KDE packages, Stack Exchange, and then you could add a list of repositories, which is more things at once. So we create a report, and now this takes some time. Now it's analyzing. on the backstage, and then we will get a dashboard. And that's the good thing of Cauldron. So Cauldron is a limited version of Grimoire Lab, and then here you get the dashboard. It's still running, so that's why we don't get it. You have to think this is that's why it took because you can then save the reports, and then you can compare with other projects and so on. But this is here done live, so data is still being collected, and you will see here shortly the results. I don't know how many commits. It has 11,000 commits, so it's already certainly large project. So it may take some time usually it's in the order of minutes. If it's with 10,000 commits, it shouldn't be very, very long. And then we can see the type of dashboard that we have. So even without numbers, look, we will have here activity. Here we will show the numbers. On the right hand side, we will have a chart with the number of commits, and it tells here what you read there. Then you have number of authors, the number of authors over time, and what it is. And this is for activity with commits, because you can do it to issues, reviews, and QA. And you have a community with the same, and then the repos, and then you can compare and have more details. So let's see. Well, this is the summary. Let's see when we have it. In the meantime, I'm going back to the slides. So this is, as you see, the idea is that you get dashboards as this, and you can then analyze your projects in an easy way without having to set up anything. You don't need to create an account in Cauldron. Actually, if I'm using this now as anonymous, as you see. If you want to create an account, then you can save your reports, and that's interesting. If you can then have your reports there, and you can show them, and you don't have to wait as I'm doing now here to the dashboard being created. And then that's the advantage of having an account. Provides you this type of things that you don't have to wait. So thanks for visiting. So this is the summary. Let's see what happened. Why is this? I don't know if it's still working or not. Yeah, it works. Yeah, it works. And look here, we see the total number of commits. Ignoring pull request merge commits and so on. Last year, and it has fallen. You can see here in number of commits. And actually, you can play a little bit around. It says how many during. This is weekly. And you can with the graphs, you can download them and do things. I don't know what this stands for now, but you can do things and you can recreate it and so on. So, and here the same for authors, the commit authors, how many in the last year, and this is on a weekly basis. I guess if you press here, I don't know why this doesn't work now, but it should change and zoom in, zoom out, and so on. And that's the summary. And you could have here for activity, you could have it in longer version, and then you can have here more and different types of angles. By week a day. Look here. You see that means this is probably a professionalized project, because on weekends there's less activity, and you see during the weekday by hours of the day. This is UTC and so on, and then you see here by numbers of the day and the week and so on, and then this is if there are many other if there are other repositories and so on. So you can see this type of things in some activities. Let's see. This was an activity. So this was on commits. You have the same for community. Active authors on Git. For on a weekly status. But you can get more information with this dashboard, and the aging, the retained, and then it tells you seniority and related, onboarding and leaving the project, and here you have the organizational diversity. Here, as you see, it looks at the this is done now on based on heuristics, which is not very exactly. So it takes the email domain. So people come mainly from Gmail. But look here, opermrs.org. There are 2 authors coming from, and you see here, no? And here also the number of commits. So here's number of authors, number of commits. And then, well, as you see, many of them are anonymous, but most of them come from openMSR.org and so on. And you have here, as you can see, very interesting information. Well, we only have 1 repository, and then you have here more details that you can do, and you have here, that's the public dashboard, and here you can play a little bit more with the information. So this is, as you see, very hands-on. And especially if you link this, oh, sorry, I'm gonna go back. If you link this with the what we saw the other day on Wednesday, when we were talking about assessment, this links very well with assessment. Remember, we were talking about lots of metrics in OpenBRR about quality and community and so on. And that's the way we've advanced a little bit. You have here many of those metrics at the tips of your finger, you know, and you can see this here. So for instance, if we go for Sahana Eden, so Sahana Eden, you can do the same. Let's say here in GitHub, we go here, and this is the repo. Let me go here for Cauldron again, and let's compare. And I need to first do reports. I did it twice for whatever reason. Let's do a new report. No, Eden. Just with Git. Add this. We could add, of course, that's what we didn't do in the previous one for OpenMRS, MRS. We could have included all the repositories. We just included the core one. So now this creates a new report, and and while it creates a new report, well, this is about Cauldron and a little bit about bin channels. That's not that important, and what we've seen and what you get. So this gets then analyzed, and then you can do the comparison. And sometimes this is useful if you want to select one software for your organization, or you want to compare which one is bigger and how, whether bottlenecks are, and compare one to the other one. So as I say, from our experience, Cauldron is better for the inner side of the projects, in the sense that you see where the bottlenecks are and what is going on. For comparison, it's always more difficult. It's not that easy to compare things, to compare projects because they are different and so on. So as I say, this takes a little bit, but it then provides you the dashboards ready to be used. And then my hope is that we will have the data soon. How many commits we have here? 14,000. So it's in the same range as here, the 11,600 that we had here. So this is the main branch. So that's why the numbers are different when we look here at the other ones. No, this is probably just giving the main branch, and then in what we analyze here in Cauldron, you get the commits for all the branches, and because we can analyze all the branches and so on. So that's why sometimes the numbers differ. So this may take 1 or 2 more minutes. So as I say, it's cauldron.io. You don't need to have an account. I'm doing this anonymously. Of course, if I log in, I have many reports there, and I can store them, and I can take them and show them, and well, I could have my own thing. So here, if you look, there is an overview of what we have, and you can see the different data sources that you have analyzed. You have a data workspace where you can work with them. So this is, let's say, made very user-friendly. takes some time because it's lots of data. You can export data in badges. Here you can export the data, the Git commits, and so on, and then you get the different here the SVG file that you get as a result, and so on, and you can compare. That's what we are going to do now, and then the actions that we've been done and the data sources. You can see that what we've been working here. So let's go here. So this is still in progress. Oh, this is the data source. So this is still in progress. So you can refresh. That's another point. When you come here, you can have an analysis from last week, and look, it's analyzed. So and then you can say, okay, this was last week, but now a few seconds ago, but last refresh 1 week. So you can refresh all data sources, or just refresh one by pressing here, and then it updates to the last date. And the nice thing, when it does it, it doesn't take that long, because it just takes the diff, the delta from the last part, and then you get here. Well, this is things that you can do with the data enrichment and so on. So let's go here for the overview, and then we see a little bit more commits, because we take all the branches and how the number of commits have been evolved in the last time. You see here from the number of authors that is smaller than the other project, and so on. And you can do again the same. Have a closer look at the commit rate. And here, look, this is interesting. This is a less professionalized project. There is less activity on the weekend as well, but in the other one, the difference was so much higher that you see, okay, these people work from Monday to Friday. That usually are professionals. And when there are more volunteers, Saturday and Sunday come up, and you can see here, there's heavy development here on Sundays. The best day is here's Thursdays. No, look, Wednesdays at 10 in the evening. That's where 20% of the commits come. So you can see those kind of things. So what were we going to do? Yeah, we were going to come here, and we would like to. Well, here we have your reports, and here we have other reports from other people. So there are 4,600, and you can see them. So I'm going back to my 3 reports, and what I would like to do is to compare. So let's say this, and whoops, that's one, and that's the other one. And then we can compare here. Look, in number of commits, the overview. So this is probably the last year. So you can see where there is more activity. So when I put GIAN, that was open MRS, and we don't see reviews, and we don't see pull requests and so on. This is for the GitHub. Therefore, we would need the token. But you can see here where there is more activity. Look, in Sahana Eden, there's more activity. It's interesting. This got reviews and issues and so on. Commit activity. And let's go here, and you can compare what is happening in the last in the last year. This is now the last year, but you can change it here to all time of the project history, and you see here so you see that's the one is younger than the other one, but it has had always more activity. But the maturity of the open MRS repository can be seen here, and then community. Let's look. I like community always. Community metrics a lot. This takes a little bit. This is from the last year, and see there's more diversity of authors in the open MRS than in the other one. So and this is last year. Let's look for. Oh no, this is all time. Let's look at the last year. Last year. In the last year, maybe it's still more authors in open MRS. So as you see, this is Cauldron, as I say, it's a nice tool to play around. It provides a lot of visualized reports in a nice platform to explore. It's like the assessment and the analytics in an easy way. So that usually you start using Cauldron. That's why I show it. It's easy. Then sometimes you think, okay, I want to do a specific thing because I want to see how old the Linux is and so on. Then you go to Percival, and then you start using more components, and at one point, if you are interested in this area, you finish using Grimoire Lab. But that's a process that takes some time, of course. And as I say, this is state of the art. This is used by the Linux Foundation for their CHAOS project. They have a project, and they have a every once and then, I think it's a regular report for all the projects that are under the Linux Foundation. Linux is one of them, but there are many other projects, and they offer this data to all their projects. The Linux Foundation, I have to say, has many industrial projects, so there are lots of companies there involved in the projects, and that's why they find it so insightful and so useful. Final remarks for this part. So there's a lot of room for improvement. So I've shown just state of the art. These are all open source tools. You can go there. I haven't shown that, but if you go for Grimoire Lab, and this is the web page. No, and you can see all this. No, this is a picture I've shown here before. Actually, I've shown a slightly different picture because they have here more elements even than what we had. And then here you can see the different repositories. No, the Graal is the latest one, the latest component. But if you go here for CHAOS, you see there are lots of Grimoire Lab repositories here. No, and it's something that is an ongoing effort, and it's getting a lot of attention in the last day. So there are many other aspects that are than the ones you get in the default version. So you can always explore your own. There is Perceval, and you know how to extract the data and get the data, and you can always. It's important to refine what is important to you. So it depends on your goal. So metrics, you can extract tons of metrics, and that's not the relevant part. The relevant part is, what is my goal? And then I choose the right metric that I think is in line with that goal and tells me something meaningful. And then I can do the exploration and the analysis. Of course, there are always new ways of making data useful. So this is just one way, and this is something that is ongoing. There's a lot of research in that. I think the important thing at the end is that you can tell interesting stories based on data. It's not, and this, if we were talking before about the cathedral and the bazaar, so this was a report on experience. Here, which is good. It's a nice first step, but here it's you can report something based on data. So it's not only experience, it's also backed up on data. And that in certain circumstances, usually in the professional environment, that's very important. It's not your opinion against my opinion. It's what I think and what I see from the data is then my opinion is stronger. Visualization is very important. You've seen we get here lots of charts, and getting the right chart is as important as telling the right story. Telling the story correctly is sometimes difficult. Creating the chart is also difficult. So the good thing is there are many libraries to create charts nowadays, and but it's an art still to make the correct dashboard. It's nice to have high order metrics. Sometimes we go too much into detail and then you have tons of data. The thing is to find those data and to the correct refinement to talk at a higher level of abstraction so that you can see what is happening and you transform a myriad of data into something which is to the point and meaningful. And at the end, it's always simplify results, make them meaningful. So from all these things, we have so much data, we could tell so many stories. The thing is, by simplifying, you have to, you can tell the right story and make it meaningful. If it's about pull requests and the bottleneck, then look carefully at pull requests, look if there's a bottleneck, look what happens, try to understand it. So as a summary, here, if you don't have data, you're just another person with an opinion. And we fortunately, we have a lot of data. And unfortunately, having the right data is not easy, as you have seen. So the problem is not having data. The problem is how to choose the right data and manage it in a nice and interesting way. So Grimoire Lab and here Cauldron and Percival come to your help, and yeah, and that's the output of all this of what I've shown you here with the software analytics part. So as I say, that's everything on my behalf for this session on software analytics. I think we still have plenty of time, because if I'm not mistaken, I still have like 20 minutes for this session. And then the other one. Well, it's 20 minutes until the next starts, if I'm not wrong. So really, we have 10 minutes now if we want to keep the small break that I think we all have gained a small break where we can stretch our legs and not sit in front of the laptop or of the computer. Still, we can use this 10 minutes for any type of comment you might have, and or any kind of question. So I'm open to take questions, to anything you might say. Then here we still have some time. So I hope you have liked this part on analytics. This is very, very state of the art. There's a lot of effort going into there. And there are a lot of interest from companies who are getting into open source, and their business model is based on open source. Then they want to know and want to have data and not just opinions, and that's why it's really important. And I think after looking the first day about the philosophy and the legal part, on Wednesday the business models and the assessment, and today about the processes, understanding that software analytics is very important. Is, I think, the correct way. So that's why we had this path in this course, and I hope you have found it useful. Yeah, Dr. Kuljit?
Yeah, that was a lot, Gregorio, to present just in, like you can say, in a go. So we really hats off to your dedication and your the kind of your expertise you have and the way you share it. Really hats off to you for that. So we really appreciate. And one question related to this is, for example, if our students are interested in this platform, so what do you think? Like, what can they explore this platform for? What could be the questions that they might be looking for answers?
That's a good question. Just one example of use is, in many courses, you tell them, go to an open source project and choose one and start collaborating with it. So they have to decide which one. And then the point is, try to do it with a project where there is some activity. And this way, this provides you a way to see if there is activity. Because if you choose a project that is dead, let's say no activity, then it's sorry for saying that, it's stupid, because you sent a patch and then nothing happens with your patch, and there's nothing more disappointing than having spent some time and nobody cares about the patch. So that. For instance, I always tell my students, go to Cauldron.io, have a look at the project. Sometimes you say, I want to use, I don't know, a photo sharing application, and there are 20. And then this is a quick assessment of which one are more active. You can look at the programming language and so on, and then you choose one. And then the chances that you choose the right one are higher. And that's one thing that your students can do. The second thing is, sometimes they have to create a software for their final assignment or whatever, or the final degree assignment. So one thing that they can do is they can retrieve the metrics and say, look, here you can see how many commits I've done for how long, and even if I've worked together with other people, you can see how many other developers have collaborated, and that's another thing that we see often for our students. No, and then finally you can do the assessment of a project. I mean, it's when you have to choose something, you can tell them, yes, do an assessment and a quick assessment, and why did you choose MySQL and not Postgres and things like that. So that are the, let's say, the use cases that I see for students.
So I think it will be interesting if they just sit and explore. So much data is available, and I mean the reports, they are very interesting to look at. The kind of visualizations are available. So I think they can enjoy just sitting there and exploring the data.
And on the other side, I mean, I was thinking about students, undergraduate students, and so on, but for postgraduate, and that's why we have to do a seminar and know that you tell me what you are working on, and using this type of data, usually what it does, it backs your research, because much of your research at the end is on this type of things, and then you can have data, and you can back it with arguments and so on. And I think for the research part, it's also as well very, very interesting. So that's for postgraduate students. There's a question here by Poonam. So I would like to thank you, Poonam, because she has been very active these days. Even in the Kahoot, she was one of the winners. So well done, Poonam. I'm very happy to that you have been part of this course and very, very active. So it's always fantastic to have students like you. So she's asking, can these software analytical tools be used by companies who are looking for some OSS software to be implemented for some management or operational tasks? What things they must keep in mind to use this analytical tool? So this is a very good question. So if you remind what we saw on Wednesday, then there were many things that were related to metrics and to the community and so on. So you can use these tools to make an educated decision about what tool to use, and this is what companies are using them for. I mean, the more professionalized you get, the more you use these tools, because the more information you want. You just imagine you go to a company and you work on a project with 100 other developers, but only 10 are from your company. So you are always very eager to understand what is going on beyond your company, because with your teammates, you can ask them. But what about the other 90 developers? You don't know about them, but you can see their activity in the repositories. So for instance, if you start collaborating with Open MRS, you could see who's active, and you could also know, when you know your community better, you can enhance it. And that's why especially software analytics is very interesting when there are lots of companies and there's lots of money involved. They want to know more about the project, and that's why it's very relevant in that situation. So I hope this has answered your question. So well, what must keep in mind to use these analytical tools is always there's so much data, and there are so many metrics. Think before using a metric. So the relevant thing is your goal, not the metrics. The metrics is a mean, and sometimes we forget about it. I mean, sometimes it's like, look, lots of metrics and lots of charts and no. The important thing is the meaningful chart. Maybe it's only one chart or two. No, but these are the ones who answer the question. No? And that's sometimes the most difficult part, because you have to filter out and select the source and the data and so on. So that's the thing that you should keep in mind for that. And that. So I hope now I've answered both of your questions. Yeah, thanks, Poonam. So I don't know if there are any other question, if there's any other question or any other suggestions. I see there's as well Munish there. Hi,
Yeah, yeah.
Munish.
How are you, Robles? I was listening to your this lecture. I think it's really good to get some of the good analytic tools to know basically. And one of the comment that I want to make, the first tutorial, I love that tutorial, the way you presented on the legal issues and how to know which type of the licensing basically. It was a really good exercise. I really appreciate that effort also. And I have a few questions or the doubt in that because I'm also working in the domain of mining open source repositories. The most of the time we found the problems of finding for the official repository, because there are multiple forks for the repository, to finding the particular repository. Sometimes it might not be available on the web pages. We need to explore, because if we work on the mining of the repository, it's not only about one or two. If it's going to be a coarse-grained kind of analysis, we need to have multiple repositories, even in thousands. So in that case, what would be the better way to explore the repositories that are the main repositories? I mean to say this, because this is the thing that we mostly feel and face while we are downloading the repositories from the GitHub or by some other source. Yeah.
Yeah, that's a really good question. So one of the things, no, as I was saying before, because we have the data and the metrics, we usually tend to have lots of data and metrics. And the other thing is, because we have the tools, sometimes we get too fast on the tools and put the repositories without thinking if they are the correct repositories, and that happens quite often. The thing is, there's here no silver bullet, and the best is usually to ask the developers themselves which is the right repository. That's if you don't know it, no, because sometimes we analyze projects and we don't know much about the project, no. And the first thing is you can look at the web page and you can find out which one it is. So it's difficult to do it in an automatic way. And the other thing is, if you don't find it through the web page, I always think, and that's one important thing, is to talk to developers. That's very interesting because sometimes when we analyze data, we don't understand what we are analyzing until we get the context. And the context is very relevant. So there was once a paper which I reviewed, and then it was the results were astonishing. They were like very incredible and so on. And then I looked at the repository and I said, this cannot be true. And I ran our tools. And what happened is that there were not human committers doing the commits, but there were bots. So they had 3 different bots. The thing is, they had the same name as the humans. So the humans used their account to use the bots, and then of course this skewed the complete analysis. And that happens quite frequently. Another point is, for instance, we saw a project, and it has the time to close. It was always half an hour. It was the fastest project around. We said the fastest project in the Western part, like in the in the Western movies and so on. And what happened is it was done automatically. So this was a fake metric. But of course, if we didn't ask I asked the developers, what's this? And they knew, of course. Oh, what we do is, if there is nothing in the first half an hour, we just close it. No, because this is very fast. So somebody has, if not, we just close it. And then this was very relevant. So sometimes it's not only about the tools. It's the context. The context, to have the context, it's very difficult. If it's your project, then of course, the context, and you can explain better. But explaining a project that is unknown to you, this is a first way of entering, and sometimes you have to filter out, and this is provided you by the context, and that's what you are pointing out, Munish, and that's very important to know. Just not like tools, let's go. No. Sometimes the context is very important. Yeah.
Yeah, because one of the areas in the terms of you have already said that the boats are there, they're automating the commits also, some false commits into the main repositories. So I have seen many of the papers onto that. If somebody they want to know what kind of commit it is, either it's done by by a human or by a bot. So there are many papers now coming onto that part. That's why I asked that question that how to recognize. So I just want to get these things from your side. I think it's really good to know these things. Yeah, thanks.
Yeah, thank you for your contribution and your questions. Yeah, very insightful. So this is a corner, of the of all the part that I didn't mention. No, that sometimes you don't have to trust all what your tools give. Always have a critical point of view of what you get and think if this makes sense or not.
Yeah, one thing I also want to mention, when I was doing my PhD, I read many of your papers. Yeah, I think there are many papers. There are some authors that you look for. Basically, there are many work that you have done on the mining of the repositories. So it's really good thing that we have you in this kind of GIAN coach. It's really helping us, and I think our participants also gained something from some of the concepts. I think it's very hard to get these things from the paper itself, because these things are not existing anywhere, and moreover in our country itself many of the things are not, it's not the most of the thing, it's not like academic and industrial kind of collaborations. We are not into that part, so it's always tough to get the things onto the right manner when we're going to start with the research or something. So there are many students in this also, even some practitioners and the researchers. So definitely with your words and with your expertise, they will definitely gain many new things, and they can explore the area and the domain of this open source, this beautiful area of open source software, as well as free LIBRE open source software. Thank you.
Thanks for the feedback. It was an honor. It was a pity that I couldn't be in India with you face to face. But that's life is like that. And this 2 years, last years with pandemic, have changed a lot. But online is better than nothing.
Definitely, we are looking forward to have more research projects and many collaborations with you in the future. Also, it's just a start. Yeah, you mentioned right. If it would be offline, it's gonna be good for us also. And because I have a few of the sessions in this program, I can feel the pain of delivering in front of system, and it's gonna be really tough, basically. And even when somebody is not, it's not gonna be an interactive session. It's really hard to deliver. I really appreciate your effort. I think it's really good that the matter you have delivered and the way you have taken up this course. It's really good. Yeah, thank you.
Yeah, thank you, Munish. So I appreciate it. So if I'm not wrong, and maybe Dr. Kuljit can correct me. So like in 5 minutes, we start the next part. Is that correct?
Yeah, we're gonna start with a validity session at 4. Within 5 minutes. Yeah. 4.
Which is in 5 minutes. So
yeah, within 5 minutes.
Shall we do a small break?
Sure. Sure.
If there's nothing more on here on your side, any of the students, no questions on, we can have this 5 minutes, and then we start again at 4 o'clock. So let's do that. Okay, yeah, then I'm writing it here, so we see again in 5 minutes. So thanks again for your attention to this session, and we see each other soon.
Okay.
Sat Shri Akal, sir.
Good evening, sir. So, good evening, everyone. I welcome you all to the valedictory session of this MHRD GIAN sponsored course on free LIBRE open source software and underlying technical issues and the legal issues, organized by the Department of Computer Science, Guru Nanak Dev University, Amritsar. Today, we have with us our worthy registrar of Guru Nanak Dev University, Dr. Karanjit Singh Kaulo, as a chief guest, Dr. Sandeep Sharma, professor and the Dean of Faculty of Engineering, Guru Nanak Dev University, as a guest of honor, Dr. Gregorio Robles, professor at the Universidad Rey Juan Carlos, Madrid, Spain, as a foreign faculty for this course, and Dr. Pulinder Singh as the local coordinator of the GIAN program. Last but not the least, our course coordinator, Dr. Kuljit Kaur Chal, associate professor in the Department of Computer Science, Guru Nanak Dev University, Amritsar. On behalf of our team, I sincerely thank and acknowledge you all for making this event a reality. I extend a warm welcome to all of you. Before we begin with the other proceedings, may I ask Dr. Kuljit Kaur Chal, coordinator of this course, to present a report on the conduct of this MHRD-sponsored GIAN course. Dr. Kuljit Kaur Chal. Ma'am, please unmute yourself.
Okay, so thanks, Manish. I welcome the chief guest of the day for this session, Professor Kano, Registrar, Guru Nanak Dev University, and Professor Sandeep Sharma, who is the Dean Faculty, Faculty of Engineering and Technology, and Professor Robles for this session as the foreign faculty for this course. So in this course, basically the course on free LIBRE open source software and the underlying technical, social, and legal issues, we had planned 14 lectures and 5 tutorials. So the lectures were planned around the topics covering social and philosophical legal aspects, history and evolution of open source software, business models, development processes, community formation, software quality, security, software analytics, and humanitarian open source software. And there were 5 tutorials which were for hands-on experience with the various tools like OpenBVR, Git, GitHub, SonarCube, Cauldron, and Percival. In all these lectures and tutorials, people like the participants, they have been given different kind of experiences, theoretical as well as a practical way to explore open source software. So for conducting this course, I acknowledge the time and effort of my co-presenters, Professor Robles and Dr. Manish Saini. Starting from planning the course up to execution, I appreciate their dedication and active participation for making this course successful. As far as the participants are concerned, I really thank all of them for being part of the course, and I hope that they would be able to keep up the pace of learning the topic and further exploring the resources that they have been introduced to in this course. I also acknowledge all the support we got during this organization of the course from both the departments, like Department of Computer Science and Department of Computer Engineering and Technology, especially for the technical support. I really thank Professor Sandeep Sharma for being available all the time. And I also want to acknowledge the support we got from Mr. Arminder Singh from Department of Computer Science and from Mr. Pushpak Dhawan from Department of Computer Engineering and Technology. Pushpak did all the back-end job of managing all the meetings and related stuff, and like I could focus more on the content that we were covering. Last but not the least, I thank the university authorities, Vice Chancellor Sir, Professor J.S. Sandhu, Dean Academic Affairs, Professor Hardeep Singh, Registrar Sir, Professor K.S. Kano, Dean Faculty, Professor Sandeep Sharma, for all their vision, help, and support for conducting such programs for the benefit of the students and the faculty. So I really hope that in future we can look forward to more such programs and more such courses. Thanks.
Thank you, ma'am, for reporting and sharing the details on the conduct of this course. Now, may I call Madam Poonamji, one of the participants, to please share his views and the feedback regarding the course.
Thank you, Dr. Munish. Good afternoon, everyone present here. I am Poonam, Assistant Professor in Department of Computer Science and Applications, MCM DAB College for Women, Chandigarh, which is affiliated to Punjab University. I joined this course with the hope of learning about free and open source softwares, and I must say that I have learned a lot of new concepts and terms for which I am excited to explore more, and many may look forward to contribute to some open source project in near future. Well, the project topic is very relevant for all of us belonging to computer science fraternity. This is the time to move forward using more and more source software as they are developed with the contributions of users and developers who are actually devoted to the technology being developed. Regarding the resource persons, Dr. Gregorio Robles, Dr. Kuljit Kaur, and Dr. Munish Seni explained the concepts in such a way that all of us could easily understand the topics discussed. The course was a good mix of concept discussion and practical demonstration, though due to the time constraints, I could not complete all the practical work along with the sessions, but I still have enough startup knowledge to explore more in this area in depth. Practical demonstrations followed by some assignments given to us and time given for completion of them could have been more beneficial to us. The length of the course was relevant. It was for 5 days, and durations of lectures were also apt, with a few minutes of break that helped us in refreshing ourselves. Conducting online course has its limitations, but I must say that I got this opportunity to learn from Dr. Gregorio Robles, which was otherwise could not have been possible. I also appreciate the knowledgeable sessions by Dr. Kuljit and Dr. Munish. We all know that a spark is needed to begin a fire, and I must say that this course has ignited a spark in me to explore a new field that I have only heard about and never tried my hands on. For me, OSS was only freely available softwares or tools, but this course, I learned that a vast world of countless contributions who are contributing in developing softwares, tools, and platforms for people like us, and that massive development work is being done in this field. I thank the organizers and the resource persons for sharing their knowledge with us, and we will look forward to such courses in future as well. Thank you so much for giving me the opportunity to give my feedback. Thank you, sirs.
Thank you, Poonamji, for your comments and the feedback. Now, with due respect, may I request our worthy registrar, Dr. Karamjit Singh Kalu, to address our audience and share a few words of his wisdom with us.
Thank you, Manish. First of all, I think I would prefer myself to be called a professor in computer science rather than a registrar, because that looks like a office person doing some file work and other things. So, because this course is related to computer, so I was really excited when Kuljit came and said, "Sir, we want to invite you for validity function," because otherwise I'm lost in all the file work and all the bureaucratic work whole of the day. So this was a very good opportunity for me to interact with people from my own field and faculty. So I acknowledge the presence of Professor Robbie's, Dr. Kuljit Kaur, she's the coordinator of this course, my dear friend Sandeep Sharma, and all the participants who have participated in this course. And I think you people have taken a very important field in computer science, especially this free and open software, source software. And technically speaking, the professors who have given the lectures, they must have explained what it is. But otherwise, if you ask a layman, like I used to use that Apple phone quite a few years back. But once I shifted to Android, and the experience is totally different. because it is an open software, it's an open source software. So the experience here is totally different. And what I feel is that in case of open source software, it's a very good opportunity for everyone to participate. Maybe it is just one person's idea, it starts it, and then all other people they come together to develop the system. So especially for a person who's the beginner in coding and programming also, it's a good opportunity where he can get the experience, what the code looks like, what the software looks like, and then he can share his or her ideas on development of the software. So it's an important topic which have been taken, and I'm very sure all the participants who participated in this course must have really enjoyed this opportunity. Otherwise, if you kind of conduct a course on operating system or data structure on networks, I mean, it's a kind of theoretical kind of thing. But here I know Kuljit was discussing with me that they have done some practical works also. So congratulations to you, Dr. Kuljit, for conducting this GIAN program on this topic of free and open source software. And my thanks to all the resource persons who have contributed in this matter. Thank you very much, and wish you all the best, and wish you all the participants a very good time ahead in this field. Thank you very much.
Thank you, sir.
Thank you, sir, for your valuable inputs and the remarks. I will correct myself. We always consider you as a professor in the Department of Computer Science. And one more thing, you are the one of the pillars of our department, and we have learned a lot of things from you. And I really appreciate your efforts that make us learn many new things that we are having around us. Yeah. Now, may I call Dr. Gregorio Robles, our foreign faculty for this course, to please share his views with all of us. Dr. Robles.
Thank you. So for me, as I've said already before, it was a pleasure to be part of this course. Thank you, Dr. Munish, and thank you, Dr. Kuljit, for making it so easy. As you probably have noticed, I can speak for hours on free open source software. So at the end, even if I've been teaching for 14 hours, now when I look back, I say, oh, this was not that long, and I would no. I had so much fun that it was long. So I'm also very grateful to Professor Kalon, Professor Sharma, and all the Guru Nanak Dev University for this opportunity. For me, it has been a great opportunity. As I have said already, it would be fantastic if I would have been in India and let's say benefit more in the face-to-face interaction. I have to say that online, I've seen that the participation is high, it has been a really nice experience to be here. So I'm very grateful. Again, thank you.
Thank you.
Thank you, Dr. Robles, for your promising and the valuable remarks. I hope this academic collaboration will continue in the coming future also. We will be looking forward to having many other academic programs and other research activity in your collaboration. Now, may I request Dr. Sandeep Sharma to please say a few words and also convey the formal vote of thanks to our worthy chief guest and all other dignitaries. Dr. Sandeep Sharma.
Professor Karanjit Singh Kalu, Registrar, Guru Nanak Dev University, Amritsar, the Professor of Computer Science also, Professor Robles, GIAN, Carlos University, our both, you can say one of the pioneer coordinators, Dr. Kuljit Kaur, Associate Professor, Computer Science Department, Dr. Munish Saini, who is the youngest faculty member of our department, Computer Engineering Department, as well as my dear participants. Today is not the last but the least day for the GIAN program on the free LIBRE open source software and the underlying technical, social, and legal issues. So, well, I think there is two myths for any open software whenever you have to learn about the open software. So one is the freedom of use, and the second is that is the free of cost. So generally what happened that whenever we are talking about the open source software, so it means there is always a confusion in our mind that what is exactly this open source software, whether it's a freedom, this is giving us a freeness of a use, as well as whether it's a freely available, everything is available on the internet. Just like as I'm taking an example of a Python language, because Python is readily available and it is such a dynamic language that is a worldwide everybody is using that one. So it is an open source software. So whenever we are talking about the Python, so everybody is saying this is the free of cost available. You can download this one, you can use that one. But more promising is that is there is a freeness available. The codes, as Dr. Kalo has already told us, okay, these kind of softwares which are actually the codes are available on the internet. You can use, you can access those particular code. And if you want to make a changes, or either if you are having a new ideas into your mind, so you can send this kind of a software to their R&D. And after the R&D, it means if these software codes are good, so they can put in their library. So I hope this program, you have understand that what is the other liability as well as the issues which are associated with this open softwares are there. So this is not a very first program that we are conducting within the association within the Spain. Earlier, we had also conducted one workshop on networking using Wireshark as well as the GNS3 in collaboration with the University of, I think the spellings are JAEN, but I think Robles can tell us it's a University of GIAN, I think so. If I am right, it's a University of GIAN. So we have conducted, at that time, I was the coordinator of that course. So I hope in the future, we will conduct more programs along with, it's not only with the, you can say, Guru Nanak Dev University, because we're having so many universities in India, those who are having a GIAN programs, they are conducting. So definitely all the participants who are participating over here, so definitely they will prefer to listen you more in the other universities platforms also. Along with, now it's basically the COVID time and we having a restriction that everything is we are conducting online. So but natural, definitely offline days will be coming soon, and we will see you over here in our Amritsar Guru Nanak Dev University face-to-face workshop. Well, now it's a times to wind up the program. So first of all, I would like to thank our worthy Vice Chancellor for encouraging all the time us to organize such kind of a program. So earlier that whenever this program has started, the GIAN program, so we are used to conduct within the offline mode. So now our Vice Chancellor has encouraged us that you have to start these programs through the online mode also. And we are thankful to the MHRD also. I would like to thank our chief guest, Professor K.S. Kalo, for his high availability all the time for us and his time-to-time guidance for both of our Department of Computer Science, as well as Department of Computer Engineering and Technology. So this program is, I think it's purely incomplete without the presence of Professor Robles. So on the behalf of the MHRD and Guru Nanak Dev University, thank you very much for your valuable time, all the lectures you have delivered to us. So I would like to thank our GIAN program coordinator, Professor Palvinder Singh, also for his, you can say, great efforts that he is conducting all the GIAN programs from the long times for our university. And my thanks to both of our faculty members, coordinator, Dr. Kuljit Kaur, as well as the Dr. Munish Saini, for their wonderful efforts. And I would like to thank all the participants and our IT team. I'm the part of that one for providing us and all of you as a technical support. So I think with all these, I once again thank everyone and especially our opening chief guest, Dr. Hardeep Singh and Dr. Gurvinder Singh, for their valuable contribution in this program. So, thank you very much.
Thank you, sir, for your valuable inputs and the remarks. It was really good to hear very new things that you appreciated, the things that we always conduct in the department. And I really thank you, sir. Now, with all these words, I once again thank you all for being a part of this course. And I hope the conduct of this course has added a new clarity and the learning to our participants. on the broader topic of free LIBRE open source software and its other issues. With this, I also hope that you will use this knowledge in the area of your work, either as a researcher or as a teacher. Thank you. This is all with the valedictory session. Thank you. Thank you all.
Thank you, Manish. Thank you very much.
Okay, thank you,
Thank you,
Manish.
sir.
Thank you, Dr. Kuljit Kaur. And bye-bye, Professor Robles. I'll see you soon.
Yeah.
Yeah. Thank you very much.
Yeah, hopefully.
Thank you.
See you soon.
Yeah,
Thank
sure.
So we will be starting the next session at what time? Gregorio, 4:30 or?
It's in 7 minutes. We're
Okay.
starting in 7 minutes. No,
Okay.
it's at 30.
Thank you.
I'm putting it here. We resume in 7 minutes. and welcome to the last session of the course. So I would like to do two things in this last session. The first one is to summarize the most important and relevant concepts and that come out of this course, and finally give that's the second one, to think a little bit about the future, and then of course to say goodbye and close this course. So to do the first thing, I'm gonna here share my screen. I've put together here a list of myths that I would like to comment on, and that would be serve as a sort of summary of the most relevant aspects that we've discussed in the last days. So this I call them myths because you hear them around, and now you know about the topic, and you know about open source and free software and what they mean, and it's important that that I stress what here the relevant parts is. No, these are myths, and they are written all in that sense in a negative way, in the sense that what appears here, the statement that appears here is usually false, at least to some extent. I will try to explain it with every myth. So one here is when it says copyleft is against copyright law. And here that's an interesting myth, because actually copyleft is a way of trying to not have copyright law. No, the idea of copyleft is, let's try to live in a world as if there would be no copyright. That's the idea of copyleft, and that's also the word game with copyleft versus copyright. No? And that's a little bit the word game and so on. But the point, and now you know that after this course, is that copyleft is based on copyright law. So when you see a software that is copyleft, this software is copyleft because there exist copyright laws. Just what the software grants you are some freedoms that make that the original ideas of copyright law have been stretched to an extent that they are different. You don't reserve the rights, you share almost all your rights. Not all your rights, but almost all your rights. And that's the idea of copyleft. So it's interesting because what they've done with copyleft is they have taken copyright, and against the original idea of what original intention of copyright, they have done something different, which is what they've called copyleft. So the myth here is true to some extent when I say it's against copyright law. But the other side, and now that's the funny side, it's, yep, but it's possible because it's built on top of copyright. And that's one of the most important things of this course, that you understand this, because if you understand this, you understand many of the other things that we've been talking around this last week. The second myth here is free open source software does not have owners. And this is of course wrong, because as we know, we've seen from the previous one, free open source software does have copyright holders because it's based on copyright. But again, the point is, we use free and open source software as if it wouldn't have owners. That's the idea. The idea is to show that it belongs to anyone, that you could, or that you can, not could, that you can modify it and adapt to your needs and redistribute it. That's the nice thing. It's as it wouldn't have owners. It of course have owners, and the nice thing is that these owners have specified a license that allow you to do all these things. And that's here the relevant part. So that's why I put it here under a myth. And now you, again, after 1 week, you understand why this is not true. That it's partially the intention, but it is not true. It has owners because of copyright. These owners allow you, as if software wouldn't have owners, and that's the when somebody says you cannot make commercial use of free LIBRE open source software. Of course, you can make commercial use, and even you can sell it. And we've seen many business models for open source software. No, we have seen that there are many ways that people have thought of earning money around open source software. They might be different than the ones that usually have been used for traditional proprietary software, like selling license. But that's one business model of proprietary model. And actually, that's one business model that it's seldom seen today. I don't know how many of you pay for licenses in any way. So actually, I would say probably today only institutions and companies pay for licenses, if at all. And as I say, that's one business model. We have seen that software has many other business models, and many of them can be found with FLOSS, and that's an important part. And of course, we have seen that this new model, not being able to sell licenses, is actually good because it doesn't allow monopolies. It gives end users lots of power. It gives you also the possibility to create a company on your own based on the effort, on somebody else's effort, because it's you are part of the community, so you can create a company and you can commercialize that software. I didn't say that, but if you have any comment or any suggestion or any thought or any question, open your mic or use the chat, because I know these myths if you know are widely heard, and sometimes you say, but I'm not fully convinced. I think this is not true, or in this situation, and then it's no problem. We can discuss about it, because as you see, I know for some myths I grant that okay, this was the intention, but you now know that this is not this way. Even if it's the intention. So the next myth I put here is free software and proprietary software are incompatible. They're two different worlds. And I've shown several examples where that's not the case. And that's very relevant to in nowadays life. And so yes, you can always use on your machine free software and proprietary software in once. That's no problem. There's even free software. We have seen some licenses that allow you to take a software system and make it proprietary. And actually many companies do that. And I was saying that probably the most used software, the ones that we use most, are those type of software. So you go to the Google search engine, and previously in the early days they used Apache. Now they use probably their own web server, but they have built a lot of infrastructure based on free software. You go to Apple, and their proprietary operating system was or is based on a formerly free software project. I mean, it's a BSD system. I don't know now if it's OpenBSD or FreeBSD or NetBSD. One of those routes they've taken, and they made their operating system out of it. They made it proprietary, and it's a problem because the authors actually allowed them to do so, and they do that the same with their web browser. If you take Safari, that's a continuation of the KHTML library that was used for KDE. So they are not incompatible. So there is even proprietary software nowadays is built to a large extent out of free software. So we say always that the infrastructure of the world, especially of the internet world, is open source software, and then there is copylefted software, which you cannot make proprietary. There is a lot of non-copylefted software, the permissive license, which you can use. And nowadays, all these JavaScript libraries, all this many of the Python programs, of the R programs, they have a permissive license. So they're not incompatible. It's part of the schema, and it's part of their strength. So we know that's something that you might have in mind when doing something in the future. So next myth is you cannot merge free and proprietary software, which is a corollary of the previous one. Well, we now know there is a concept there which was license compatibility, and there are some licenses which are more difficult to be compatible with. Mostly the copyleft license. The most known one is the GNU GPL. But there are other software licenses where you can use, where you can merge free and proprietary software. These are like the permissive licenses, even the weak copyleft licenses. It's a library which you can use, and it can be linked by proprietary software. So actually, you can merge free and proprietary software. There are some software systems which are open source that are thought for that, and that's actually not the problem. They want to be distributed as much as possible, and if you and used as much as possible, and if you use them in a proprietary environment, that's no problem. That's what the authors think it's right. It's better that somebody uses our library, even if the result is proprietary, than that these people don't use it. And that's a little bit the idea. That's why this myth that it's not true. No, it's you cannot merge some of the free software, but the other you can of course merge. So let's see what other myths we have. I've put 10 together. We're half of the list through now. So this is important. And I think we haven't talked about that, and so that's one of the things that I missed now in my lectures, because I had to talk and to present so many things, so I didn't have time for this. Here, you are obliged to publish your enhancements in free open source. So let me put an example. You download the software, and then you adapt it to for your organization. And you can do that. You can take it, and you are free to adapt it and to use it. So that are two of the 4 freedoms that we were talking on the first day. So here comes the next step, and that's a freedom. So it's not an obligation. So you can improve the software, and you can share your improvements. But notice that that's a freedom. You are not obliged to publish your enhancements. And actually, this is a nice business model, and it's partly what makes Apple taking a BSD operating system, and they enhance it, and they aren't obliged to publish their enhancements. And even that's one might think that's because it's a permissive license. That's true. Google does the same with copyleft software. They can take the copyleft software, they can improve it, and because it's running on the server, they're not obliged to publish the enhancements, because what you are doing, what actually the users, being it server software, they are the users. It's different as if we would get the software. If we would get the software, then we could ask for the source code, but actually we don't get the software. What we get is an output of the software, which is the HTML page, the web page. So that's why Google isn't obliged to publish their enhancement if it's server-side software, and they have done it for a long time. I mean, they're still doing that, in the sense that some of their enhancements, they are kept private, and that's one of the things that you can do with free open source software. And if you take a software, you take a learning management system, Moodle, for the university, and you implement it at your university, and you adapt it and create some enhancements, and these enhancements make you different from other universities, you don't have to share those enhancements with the other universities. If you want, that's good, and the community will always be welcoming about you sharing your enhancements, but that's a freedom, not an obligation. So that's important to notice. That's why I put this as a myth. It's because this is a freedom, not an obligation. So let's move to the next one. So free and open source software is developed by volunteers and it's non-professional. It doesn't have quality. So this wasn't true 20 years ago. It's less true today. Free and open source software, as we've seen, has a wide fraction of professionalization. Actually, we have seen it's a mix between professional developers and volunteers. And actually, many of those volunteers are professional developers in other places, or they are students or academics. And what is seen as let's say, as a drawback is really something good. It's really a pro, because we have there a nice mix between professionals and between volunteers who make this because they think the software is valuable, and that's a very big improvement towards other traditional software systems. No, we were saying, Eric Raymond says, no, those developers working on proprietary software, they really don't understand their software they are making because they are not using it. Volunteers, if they come and show up, these are users that are using your software. They know how the software works. They use the software. They have a big interest that the software gets better. That's why they are contributing, even on a volunteer basis. That's why volunteers are gold. So that's why it's not bad to have volunteers. It's very good to have volunteers. And that's why this myth, which was said like 20 years ago and was like creating fear, uncertainty, and doubt around open source software, is really something that is not bad, is something that is wonderful. We have professionals, and this mix with volunteers makes the best cocktail to have a very good and valuable software. Let's move to the next myth. Oh, the next myth. I think I don't need to talk much about that. No, you cannot earn money with free open source software. And we have so many counter-examples nowadays. We have seen so many business models. No, at first, people thought you can only live from selling books about open source software, or you can only you can only do consultancy. But then we have seen many other ways of earning money, and actually, it's evolving. And and this is a thing that is many people are thinking about, and they're always looking for new ways of making open source profitable. It's true that you cannot sell licenses, but actually we were saying that that's not that bad at all. And usually if you provide value, then it's certainly a way. It's never easy, but that's business. It's never easy to earn money, but there's a way to earn money with open source software. And we see almost all companies in the world, and I think all the big IT players, they have a strategy with open source, and they earn some money with open source. From those, the Microsofts, Oracles, IBM, Google, Apple, they all have their open source project office, and they have some relation with open source. And if they do that, it's because they earn money. Companies are there to earn money. That's of course not bad. They have they pay salaries and have to make a living out of that. So that's why if they use and create software and services around open source, that's good. It makes the projects more valuable. Next myth: open source software does not offer good career opportunities. Well, that's actually not true. If you go to any job search site and you look for almost any technology, when I'm thinking about web servers, Django, in OpenStack, and so on, and you look there for the key terms, and in JavaScript and all this, then you can see that it's highly demanded. There are lots of opportunities to be an open source software developer. You have to think that if you know about open source and you get skilled in And it's not only development, the skills you need also to drive a community forward, to manage and handle volunteers that come and submit a patch. We've said before, volunteers are gold. And then if you know about the tools, the process, and so on, you're really a high skilled developer, and you are very, very valuable. And as I was saying before, it's not only the big IT companies who have all of them a strategy towards open source software. They have their project offices, they develop open source. So I think nowadays it's a good way of having a career in IT where you can have your skills on open source software development, and they're highly valued, and you have many, many possibilities. And so that's a myth, in the sense that even 20 years ago that was false, and today I would say that's even it's very wrong. So I think that there are lots of opportunities out there. I see that with my students as well here. We talked this morning about processes, and people expect that there is only one. As I say here, there's one and only one way to develop free open source software, which is what I've shown, like the bazaar style. And that's really not true. I mean, it makes sense that there is one, which is, let's try to be more open. Let's give people access to the source code, to the process, to the decisions, to everything. Probably that's the one that maximizes the practical part, and that allows that anybody may join, and that allows to attract these volunteers that are the gold of open source software. That's true, but you can develop open source software as you wish. Remember, what says if the software is open source software is the license. So you can develop it with your colleagues or with your friends as a cathedral on your own, without having to communicate with anybody, and without sharing anything with anybody. You just have your repository and you work on your own, and don't want anything from anyone else. That's still open source software. It's maybe not the I would say the most efficient way maybe of development, but nobody has to say to you how you have to develop your own software. So this is as well open source software, and it's not depending on the process you are using. Of course, if you use GitHub and make use of all the tools that GitHub provides, and pull requests and so on, then maybe you may have some benefits. But as I say, this is not an obligation. This is something that you can do. And that's something that people forget. No, sometimes they think, no, it's open source. You should give me right to access. You have the right to access the code, but I should be able to collaborate with you. And so, no, there is no obligation to collaboration. Collaboration, again, is a freedom. And if we collaborate, probably we'll get better results. But that's something that you should decide. It's not an obligation. It's a freedom, and that's why I think this is a myth. So this finishes with the 10 myths that I would like, that I want to stress, that are the important lessons from the past week. Now, when you know about these myths, you can say to people, yeah, I went to a 1 week course at university, and there was a Spanish professor and 2 Indian professors telling me about open source, and I've heard about this, and this is not that easy. And look, what I know about this is this, and you can discuss about the myths and so on. So we've seen a little bit the state of the art of open source software. We know the fundamentals, the legal, the social, and the technical issues. We've been talking a lot about that. The least part we've been talking is about the technical issues, because I know you're mostly computer science undergraduates, and the technical issues, you see them in your courses. So you know about programming, No, you know about the different languages, about databases, and about many other things. No, UML, the diagrams, and so on. So that's why we've put here the let's say the focus more on the legal and social issues, because they are usually not that much explained in undergrad computer science courses, and they, as you see, they are not simple, and they have a history and a reason behind that. And this reason is not only pragmatic. No, we have seen as well ethical reasons, no, and that's where the Free Software Foundation and Richard Stallman comes on, and so on. So if I look at the future, one of the things that I would like you to do is always, when you look at I'm gonna stop sharing because it's the firewall. So always when you take a software, have a look at the license and see if this is free open source software. This is especially easy for desktop software, and it's more difficult if you look at mobile phone software, because there are lots of apps. But have a look. There are some distributions which group together mobile phone apps that are free software. And always think about the benefits of free software. Sometimes the benefits are not direct for you, but I think if you think over what we've been talking about in the last week, I think that it has some social, there are some social benefits just because of using software. So Poonam asks, she's good at technical writing. How can I contribute to an OSS software? That was my second point. So I was now talking about OSS. So Poonam was thinking ahead and is pointing out to the next point. So my first thing is, as a user, be aware that if you are using software, you already have much power in the choices you do. And if you choose free software, then you have some rights. And even if you don't make use of these rights, just by using the software, you are making this community larger. There's one more user. This makes the software more valuable. And that's already a small step, but sometimes a significant step forward. The second point is, most of us, we have a computer science background, and we have some technical skills. And even we have been trained to be good at technical aspects and have these technical skills. So we can not only be users, we can become developers and contributors. And the point is, and that's after you start using software, so free software, sometimes it's look at the projects you use and see how you can contribute and how you can collaborate. So I'm just thinking about, just imagine if you are a sysadmin and you are using Docker containers. Have a look at the Docker project. Look how they organize themselves. Look what the code is out there. Try to download it, compile it, install it, configure it, play with it around. That's good. You can do that. That's the nice thing of the freedoms. So start doing it. Sometimes it's difficult to contribute because software is complex, and understanding the complete software system is very complex. But usually, if it's something where you are the user and you are, let's say, a heavy user of that software, your job depends on that software. And having a look at those things and getting familiar with the software, in the long term, you may finish contributing. So that's number one. So the thing is, usually contributing is not easy because source code is something that has its complexity. So maybe if you want to start to contribute to a project, maybe having technical contributions I'm thinking about source code is not the first step. Look at what other things the project lacks. Sometimes it's documentation. So one way of learning about the project is to create its documentation, because software developers usually are good at developing software, but documentation is something a little bit more boring. So you can add end user documentation. Now you see that you like one project. Just imagine Perceval, now that I've been showing before. You like Perceval and you work on that, and you want to do your master thesis with that. And then at one point you see, oh, this is difficult. There is some documentation, but not much. So I can create documentation on myself and write a tutorial on how to use Perceval on this specific data source with this backend and what I can do and so on. And that adds a little bit, and it helps me become more familiarized. You can also add technical documentation. So you can go to the Perceval repository and you can see, oh, Perceval in that sense is very well documented, I have to say. But for instance, if let me share. So I'm sharing my entire screen. If I come here, just and I'm going to go to the source code. So I go GitHub and Perceval. Oh, that's not what I wanted. Perceval. So if you come here, you can see here the code, Perceval code. And here you can look at the backends, and here you have, for instance, Git backend, which is the one we used. You can see the code, and you see here, that's at the beginning, it's always the copyright, the authors, and then here, as you see, have it quite well documented. So there's technical documentation here, and that's quite well. So I don't know if that's true for all of the, yeah, it looks like that, but you can see, there are many projects where they don't have this technical documentation, and then you can add this technical documentation. This, I think, is a nice way to start collaborating on an open source project, because usually the complexity is because there are so many functions that you don't know how to use it. But if you document them, then you get to know the API, and that's, of course, a good idea. That to start with, then you get familiarized with the project. There's a very well-known Python hacker nowadays that started like 20 years adding the documentation in the inline documentation, as I've shown here, and now he's the Hettinger is his name. He's now very well known and gives the best talks on Python. And he started like that, and he always says, start like this. Look, if in pandas there is the documentation, add the documentation, the technical one. Another way of doing it, and here in Perceval they have it, it's you can add tests. Here in Perceval there are unit tests, and for instance here test git, and they have already unit tests. There are many projects out there where you can see, and you know how to run it, but they don't use, they don't have tests, or have a very few tests. So you can add tests. That's another way of technically contributing to the project that is very valuable, and that the developers of the project will say, oh, that's fantastic. And that will help you to get familiarized to the project. You start doing tests and you finish resolving bugs. That's the way to go. And of course there are these are the ways of doing technical, but the other things, there are other types of, if you look for a project, GNOME, and let's see, the web page. So that's the desktop environment I'm using here. I'm using Linux, and this is a desktop environment. And here you see we promote software freedom. You see the picture. So there are gatherings of developers of GNOME, and one way of contributing is to contribute to the social aspects. So you like GNOME, try to make a local community of GNOME, try to join others who like GNOME, because that's the way of building something together. It's very important to have this social part. Free software is about sharing, they say. So to share, you need something to share No, you need somebody else. So here the point is build a small community, organize events and talks. Maybe GNOME is too far, but come together with other open source projects and say, we're going to have a day at the university and we're going to talk about the softwares, the projects that we care about. And look, my friend, he works on, no, he likes GNOME and has been doing this. The other can talk about JavaScript and the other one about web development with Django. And somebody there knows about Docker and somebody about OpenStack. So this is already contributing to open source software. And many of us have started this way many years ago before developing and so on. So that's also ways of contributing. And if you look at the projects, they are always some local branch. You can look at, for instance, GNOME, if there is somebody in GNOME India and what they do. And sometimes they do on-site conferences. Now, because of the pandemic, there have been many online conferences. You can go, if you look again to Perceval. Oh, well, there's this meetup platform where you can organize a meetup on here on any issue. No, you can start a group and you say, okay, I'm interested in GNOME, so I would like to host an event or reach new people and so on. And you can look here. Here it says I have to sign up to look. Let me see if no, because I think this is with Google. Yep. And then I'm logging in because then you can also see what is happening there. So it's Srimdar. I have to look. So if how it's written, because my university, my Indian knowledge is not right. Let's see, Amritsar. So let's see what is there in Amritsar. So here, let's see if they find something. Yeah, they find Amritsar. Let's see. And here you can see there are already a Docker meetup there, which well, it's close by. So I see not directly in Amritsar, and no, but here you could create your own meetup and you can come together, and that's a way of sharing knowledge, getting more familiar with the community. You get to know what is happening, and and somebody can tell you the latest events that you began. And as you see, I see here, because you're close to Pakistan. There are many more in Pakistan. I see Delhi and so on. I don't see any in Amritsar. That's a pity. But it's sort by relevance. Let's do by distance. 100 miles. And no, not any. So there's no meetup there. And as I say, this is really, if you look here, my local town here in Madrid. Look, any distance and by relevance. And no, it says Malaga, not any distance. Let's put 50 miles in the Madrid region of Madrid. And why still Malaga? I don't know. That's not in 50 miles distance, but there are lots of things happening in Madrid. Here, as you see, many things, for a meetup. And then many of them are technical. So I see there, let's say Git. I'm putting Git. Learn to use Git and GitHub. March the 3rd here in Madrid. So then they organize it. So you can do similar things for in similar, and that's the way to start. I always think start small and simple. It's always a path. Remember, developers join because of learning and acquiring skills and sharing. So the process here is very important. It's about learning, and that's why I think having a career here is very nice, because it's an ongoing learning process where you keep on learning and you become, as well as a developer and as a person, more valuable because you know more and you have more experience and more expertise. And free and open source software allows you to do that because you can access the code and you have been trained to know about code and develop and the process and so on. So this, to some extent, is also a practical issue. It maximizes your skills. So that's what I would say. So I think in the future we will see more open source development. 10 years ago, I would say, because we didn't have, now we come back a little bit to shareware-like and freeware-like software because there are lots of apps in the phones here. But 10 years ago, you could say I can live without using myself as a user, without using any proprietary software. Actually, I should show there is a package here in this is an Ubuntu, which is based on Debian. And there's a nice package that's a nice joke here, which is the virtual Richard Matthew Stallman. And this tells you if you have any non-free package installed here in my machine. My machine is called like this here. No, you see, Rufito is the name of my machine. And then it tells you these are the non-free packages. I have 1, 2, 3, 6 packages here installed on my machine that are non-free software. All the rest, I've got almost 3,000 installed packages and 7 are non-free, which are here. Well, it's processor microcode because I use that's one. There are some fonts here again for the processor. Oh, I use a codec here for something. Then RAR, it's to uncompress RAR files, and Skype. No, and then here I have non-free packages which have status other than installed, which is this is here for the digital signature. So I have 7 non-free packages. And then here, this is again the processor and the Flash player. I should remove that. I don't use Flash anymore. So I've got 2, which are 2 more. So I actually, as you see, I got 0.3% of the packages that I have installed on my machine are non-free software. So I can go with 99.7%. So look at if you use Linux, install this. You see here that's the virtual Richard Stallman, and it tells actually if you put the explain, then it tells you the explanation. Let me see what other circumstances it says. Use dir as the recent directory. I should look more at the and explain is the default, I see, because sparse does the list as I say. Okay, and explain is what we've seen here, what it gives you the explanation why they are not free, or what type of software they are. So as you see, 7 out of it. So that's a way to do. So that was a small joke with the virtual Richard Stallman. But as you see, free software is around. It's good to know about it. Read more about it. I've put a lot of references in the slides. I will share the slides with you, and I'm sure Dr. Kuldeep will share the slides afterwards with you. There are lots of books out there. There's lots of free and open material out there on the internet which you can access. And of course, if you start contributing, you have you can learn about the process and you can learn a lot about it. That's I think you will notice it's a fantastic sensation when you the feeling is fantastic when you start contributing and sharing with other people. There are few better things in this life than feeling part of a community where you share with them and you get a lot of you get back a lot because you share a little bit to the software, but you get the full software back. That's fantastic. When you just imagine when you compete with big companies that drive thousands of developers and pay them, and you are competing against them with a small open source project. That's a nice point of view. So, okay, and I have just one more slide because we're coming to an end. I can imagine it's Friday evening, and I see 18 people we are in this room. So I'm very thankful for your participation until the very last day. It has been a pleasure to be here and to talk about free and open source software to you. I hope well, also thanks to the organizers and collectors. So thanks to Dr. Kuljit Chahal and Munish Saini. So thanks for giving me the opportunity to be here. Thanks for giving us all the lectures. I was yesterday with the humanitarian open source software, very interesting, and I'm sure that what Munish has shown you is also of great interest. Thank you to the GIAN program and the Guru Nanak Dev University. It's a pity not being face to face. I hope to be someday there in Punjab and see you, all of you, face to face. That's for me something that I miss from this part, but it's the situation is what it is. I hope you have learned a lot about free open source software. I not only hope that you have learned a lot, I hope you want to learn more and you notice that this is interesting and this is a topic that is worth keeping on an eye. I hope you had fun and you still keep having fun. And as I say, I would like you to read more on this, to experience more on this, to develop more on this. And of course, I would like to see you entering a FLOSS community and participating and thinking always, oh, I took a course there when I was an undergraduate. And because of this course, I said, oh, let's try this. And to some point, I don't want to say that this might have a big impact on that, but this changed my life. I had a different perspective, and it changed a little bit the way I was thinking, and that's nice. So thanks again. And as I say, I hope you have enjoyed it. This was all on my side. I appreciate your participation, and I hope you have a nice Friday evening and rest of the weekend.
So thank you, Gregorio, for all this content and teaching all of us. In fact, I can say I have learned a lot in all these 5 days. And as far as our students are concerned, I think they have took the content of one full semester in these 5 days. So I'm really happy that we started with some vision, with some program, and I'm really satisfied with the way we are concluding it, and looking forward to such kind of interactions, collaborations in future as well. And you're right, this will be a kind of experience in the lives of all these people who are attending it, particularly the undergraduate students, that they'll have this a lifetime kind of experience. So I think they'll find it very useful in their, future job or whatever they are doing in the days to come. So thank you so much. I can say it with folded hands like we have here in India. So this is our way of thanking you. Thank you.
Okay, so thanks also from my side. So I've learned something new. So that's good.
So I will say in Spanish, gracias, gracias, Dr. Roberts.
Yeah, thank you, sir. In Spanish, I will put it in the chat. So in Spanish, we say gracias.
Gracias.
Yeah, like this. So yeah, thanks. So yeah, so as I was saying, have a nice rest of the day. Thank you, Kuljit. Thank you, Manish. Thank you, everybody. And I hope to see you sometime soon.
Yeah, we also feel that if it had been a offline course, that experience would have been totally of a different level. Yeah. But anyhow, we have learned a lot and we have, shared a lot. So that is something good about this program. Thank you so much. And thank you to all the participants who are staying with us up till now. Thank you so much.
Yep, thank you. Bye-bye.
Bye.
Cheers.